Okay, hello, good morning, everyone. I'm happy that you came back, and we can start our second day. So welcome, good morning to all the colleagues here and also online. We will have a pretty long day today, starting with a plenary session when we will and would like to learn about the challenges and opportunities related to AI. So it's, I think, should be a more broad approach to AI-related questions. And after that, we will have breakout sessions for different topics, going into more technical details, more experience-driven presentations. Hope you will enjoy it. And after that, we will have, as a closure, a panel session and also presentation to wrap up the day and to hopefully have something to sort out in our brains about these 1.5 days. So let's start. Without further ado, I have to announce, a housekeeping rule that was also announced yesterday, that the symposium is recorded. So please be reminded of that. Also, like yesterday, we would like to have nice discussions. So if you want to ask questions, please don't be shy, do it. And the presenters will try to address these. So our first session will be a plenary session with 3 speakers. And the first speaker is already online, Thomas Hartung. Yes, hello, Thomas. Nice to see you.
Hello, Akash.
So Thomas is the Durenkamp-Twinden Chair for Evidence-Based Toxicology at Johns Hopkins University, and he's directing the Center for Alternatives to Animal Testing. He's the former head of the European Center for Validation of Alternative Methods. He has authored a pretty lot of publications and founded the paper Frontiers in Artificial Intelligence. So Thomas, take it away. The floor is yours. Thank you very much.
Yes, hello from Rabat in Morocco, of all places, where we are having a high-level conference on AI and chemical weapons. And I tell you, it's much more pleasant to talk about AI and food. Okay, I made my slides available. The QR code is also on the last slide again, and also some of the papers are marked with QR codes if you're interested. Okay, there's a team behind it you just saw. I think we can be fast. Toxicology has a problem, which is essentially throughput. We can't test all the stuff which comes to the market. This picture created with AI is illustrating this very nicely. We have data on not even 10% of the chemicals which are registered in the most developing countries. In the US, we have 4,500 chemicals we add to food. 80% don't have adequate data for risk assessment in the public domain, at least. Very different to Europe, just to say you have about 10% of this controlled by EFSA. But there's also new products coming to the market. 6.7 million vaping products were registered with the FDA, and after assessing 99.9% of them, 6 had enough safety data to get to the market. And again, these are mainly food-related compounds which are being used to flavor these compounds. And drugs and pesticides are doing better, but we would love to have tools to do this early on, to front-load toxicology, not at the very end of a 2 billion development of a drug or a 200 million development of a pesticide, and then come as a naysayer and say, we found toxic effects in rats and rabbits. There's more, which I don't have the time to discuss. At the moment, we see a dramatic increase in AI and its capacities and use. And this is because 3 exponential curves are synergizing here. The data in the world are doubling every 18 months. So 90% of all data have been produced the last 3 years. Our computers are, for the last 60 years, doubling in capacity every second year, known as Moore's Law. But AI, since the introduction of deep learning, is doubling every 3 months. So this year's large language model, for example, is 8 times more powerful than last year's. And that's essentially the difference between ChatGPT 4.5 and 3.5, if you take an example. I have a strong interest in AI. I've been working with Frontiers, with Keystone, or the World Economic Forum in the last years. But I would like to quickly address. You asked for challenges and opportunities. There's some common ones. which are well known. I had DALL-E 3 make this picture for me and asking for devilish attributes to the A and angel-like ones to the I. But if you give it a closer look, you see that the angel has a red face and a devil's tail. And I left it like this with the first prompt because I thought it's nice to show the shortcomings, the hallucinations and difficulties of AI. But I see that at the moment, many of these shortcomings are being addressed and they are more and more getting smaller. They're not disappearing, but we clearly see that there's more and more advantages of what AI can offer, increasing our productivity, helping us with information retrieval and integrating complex evidences. From my point of view, in short, AI is the answer to information flooding. We all cannot read all the stuff we are exposed to. We should read for our work. AI is helping us, and I think it is re-establishing a work-think balance to some extent. At least I would like to see it like this. For me personally, it certainly has been. The magic behind AI is that a very famous rule, which is the first 20% of work give you 80% of the result, and then you have to work harder and harder for smaller and smaller increments in success. AI does not follow this rule because deep learning is increasing continuously with increase in numbers, in data available. So most of the progress in AI has not been by new algorithms, but by having bigger databases and larger computers to crunch these databases. And this is something we should be very much aware of. So it's really about data. And AI performs better and better. This is a graph which shows how human skill levels from 0%, so all humans are better than the AI, to 100%. AI is, if crossing this line, outperforming humans, all humans, is getting faster and faster. On the very left, you see, for example, deciphering handwriting in blue. And on the very right, you see things like coding, where in only 2 years, AI has taken over most of the coding work in the industry. And at the moment, AI is performing quite robustly in standardized IQ tests at an IQ around 130 for writing tasks, even at 150 sometimes. So this is really a proposal. One of the epiphanies I had in this field was in 2022 when DeepMind, our Nobel Prize winners this year for chemistry, came out with this chess program, AlphaZero. And they did not train it at all on any human game. There's about 600,000 of them available, but they just let it play against itself. And every time it made a wrong move or did lose against itself, it learned something. And after only 4 hours, it was as good as Magnus Carlsen, the current world champion. And after 8 hours, it was unbeatable for humans. And the interesting thing, the epiphany for me was really that the AI plays different. It sacrifices, for example, more figures for strategic advantages. And now human players are studying how the AI is better than other human players. And this shows you should not only expect AI to be faster and on scale doing what humans do, but also to identify sometimes new things, new ways of doing things. Toxicology is obviously part of the revolution. I like to call this toxicology. So the AI integrated in toxicology. In essence, it is all about making big sense with big computers from big data. And this is along with the topic of your conference. Big data is at the basis of it all. If you have an Excel sheet, you don't need AI. AI will not really dramatically improve, can actually make it worse. But if you have many very different things, if you have really tons of data, then AI shines. These 3 articles from the last 12 months are all open access available if you want to go into any level of detail. But I would like to give you, with a focus on data today, I would like to give you a bit of an impression what AI can deliver already and what is coming in the near future. And I would like to take an example of a personal experience a year ago. I was the peer reviewer for a risk assessment carried out by the US EPA. And they told me that 2 people had worked 18 months on this to retrieve the available data and do some read across on this. And after I carried out my peer review, I asked, what can these large language models do to help me retrieve these data? And I tried ChatGPT 3.5, which was at the time the open access free version, which 99% of the ChatGPT users were using, and it found nothing about this chemical. When I used ChatGPT 4, which 1% of people were using and which is much more accurate and factual, I found quite a bit. But when I added to this the plugins, which allowed it internet access and retrieval augmented generation, which 0.1% of ChatGPT users were using, it found essentially all of the information. And it highlighted a paper which was found but largely dismissed by the EPA colleagues. And after rereading it, I thought the AI made a correct assessment that this should be really considered. BART did not work at the time, but Anthropic's Claude did at least as good of a job as ChatGPT. So it's not a one pony show. There's more of methods available. Actually, there's a lot of large language models which do the trick. But I was blown away when Perplexity AI found an entire risk assessment done on this very same substance, which was missed by the EPA colleagues. And this shows you really, I think, quite impressively, all of this was done in less than 1 hour. How much AI can support our information retrieval for comprehensive assessment for a given substance, and also its similar chemistry, for example. There's other data. There's, from my point of view, a treasure trove of data, of omics data, which we have to really bring into our predictions. These are mainly the transcriptomic data and the metabolomics data I'm thinking of. Transcriptomic, because it has been the workhorse of the human genome. It is highly standardized in the meantime, and has, for example, a gene ontology and reporting standards and have all of this available. And it is really a very, very much a delivering technology. Metabolomics has the advantage to be closer to the phenotype, because a gene transcript and change does not mean necessarily that anything is changing in the organism. If metabolomics changes, there is something. And I believe that this will be the workhorse of the human exposome. But we are only working on the standards. We don't have a metabolite ontology, for example, or something similar. We have initiated with our work on the standardization of metabolomics, a movement now, which is driven by many organizations like the FDA, the NIH Center Institute, and the NIST in the US, but many other organizations called MQuack, which is trying to do exactly this. The other treasure trove we have is the scientific literature. One of our iconic heroes in Hopkins is Sir William Osler. And he said, it is astonishing with how little reading a doctor can practice medicine, but it's not astonishing how badly he may do it, which unfortunately still holds. But at the same time, our scientific literature is exploding. If you just take PubMed in 2022, it added 1.7 million articles, and it is believed to represent just a quarter of the biomedical literature. So this is really enormous. And here you see the increase of scientific literature over time. It is something which is exploding and unreadable. Interestingly, already last year in February, Microsoft came out with BioGPT, a program to annotate scientific literature, and it outperforms humans in this task. So in essence, AI can read scientific papers better than humans. And also the problems interpreting a table, interpreting figures has been largely solved over the course of the last year. AI is also promising to make accessible all of the literature which is not published in English. And this is about 50% of all biomedical literature. For example, 80% of the literature on AI is published in Chinese. AI has no problem to read these. A very important movement is really that more and more science is published open access. I'm one of the original signatories of this Open Science Charter, for example, because I strongly believe we have to put our things into the open. Because even the part which is open access but only available through repositories is very difficult to access for AI. So this is something really critical. So this natural language processing, making all of this scientific knowledge available, also the one of the past, not only the current publications, is really important. And I would like to give you an example. Tom Lüchtefeld has been associated with me for the last 10 years. He is now junior faculty after his PhD. And he has created 2 companies. ToxTrack is one of them. And I don't hesitate to recommend his SysRev program because it's freely available. It is essentially supporting with machine learning, doing systematic reviews. But in the context of the EU OnTox project, a 17 million euro project where both of us are partners, we have increasingly now made this a program to extract information, natural entity recognition, causal relationships, and others, and we are trying to make this an important tool. You can see here articles abstract being screened by the consortium of OnTox on different topics. So these are in the thousands, and this helps us to really develop rules for what is relevant papers in toxicology, in our case for liver, kidney, and the developing brain, and 2 hazards each, which we are assessing as a test case. So the other source, which is really critical for making predictive toxicology possible, is databases. And interestingly, data analysts spend about 45% of their time for loading data and cleaning these data. This is an assessment which showed this. And Tom has been pursuing a concept of biobricks, which is essentially taking this work away from you. So it takes about 2 weeks for one database to analyze it and program a biobrick, which allows then a single line command to import the entire database in a structured way. So you don't have to think about what is how the database was structured, what the programming language is, and whatever. This concept has led, in the meantime, with funding from OnTox, from NIH and the National Science Foundation, to the programming of around 90 biobricks. The first 8 of them gave us 250 million triplets of a substance, a property, and a result. We're really talking big data here. Many of them are already available freely on GitHub to access these, but we have a paper on this under review. So really, I think this is a major step to make large amounts of toxicological data machine readable and computable. To show you a little bit how this has been exploding, a bit from our own work. I just want to focus on the scaling here. In 2014, we did some Bayesian network type of integration of data for just 140 structures for which we had data and skin sensitization. Very few data points, and we achieved 65% accuracy, roughly. In 2016, 2 years later, we had already 3,200 structures, mainly for making the REACH database machine readable, and we achieved 80 to 92% accuracy in predicting skin sensitization. In 2018, then, we developed a model with 10 million structures, and 600,000 of them had data. And we predicted the 9 most common toxicity tests. The classical 6-pack, and we recorded 74 different properties for these. In the end, then we evaluate this for 190,000 cases where a chemical had data, had a classification based on these animal tests from regulatory processes, and we were 87% correct in predicting them. 190,000 cases, yeah. And at the same time, the reproducibility of these animal tests in the same database was just 81%, showing you already that we at least achieve to be on par. And within on-talks, or let's say first, we later then, 2 years later, showed that we can even also predict human skin sensitization with this approach better than animal tests, local lymph node assay data here. And we showed that we can apply this in batch. In 2022, we applied this to 4,700 food-related compounds. This is the equivalent of 38,000 animal studies, which cost more than $250 million, if you find the laboratories to carry them out. And again, for a small set, 83% of them were correctly predicted. And then in 2023, we showed we can also do this for complex endpoints like cancer or reproductive toxicity. So with relatively little specific training, we were able to predict the classifications and reach for 1,000 chemicals each with reasonable predictivity. And OnTox is at the moment trying to develop this further. As I said, we have now 90 databases which we can pull in. 15 of these gave us now 254 million chemical activities on 117 million chemicals. And we have 4,000 properties of chemicals, for which we have more than 1,000 activities in the database. And these 4,000 in our current model building in the training phase showed 91% predictive accuracy on average. So 2,000 of them were better than 91%. And we're at the moment evaluating what are these and how can we now use this to predict liver, kidney, and the developing brain and create a co-pilot for toxicology, which we want to deploy to our partners by the end of the year. So this is really using literature, databases, and the internet and QSR, I have to say, and create large data sets. We are also introducing the concept of biological similarity. It's not only structurally similar like the woman and the dog, but it's about biological similarity. And this is increasing in our test runs by about 10% our predictivity. And this is used to predict the probability of hazard, a very important concept, because I think that one of the problems of toxicology is that we wanted black and white, while in reality we can deliver shades of gray with some uncertainty. And this concept has been embraced by a white paper, 3 workshops we carried out, the last one only in July in Italy. And the first workshop report has already been published earlier this year. I really believe that AI, which is delivering the most probable result, but can also say how probable it is really making probabilistic risk assessment beautiful. A quick hint, we just published 2 days ago a paper on how AI can also help us with the validation process. So this is an idea which was actually receiving an award from the complementary idea competition. We believe we can optimize validation processes very much with AI. There's 2 more papers which come with this, which are fundamentally looking into the validation process, which I recommend you to read because they're my own. Last thing, out of a Department of Defense strategic workshop I had the privilege to steer, we came to a call for human exposome to complement the human genome. There's again a paper on this available. We believe that AI is playing a critical role to enable this and call this exposome intelligence, EI, which is at the moment being developed. And we carry out next May an exposome moonshot project, bringing stakeholders together in May of next year in this beautiful building in Washington, which Hopkins owns. And we are at the moment finding more and more stakeholders. More than 50 have signed up already, so that we are coming together and planning a roadmap towards exposomics. With this, I come to an end. I hope I've shown you that AI is one of the disruptive technologies, especially as we can combine it with existing knowledge easily. I think it will be accelerating product development and risk assessment. It can optimize prevention, public health, and democratize healthcare access. And this is based on these disruptive technologies and opens up for a human exposome to complement the human genome. Thank you very much for listening, and I hope we have time for some questions.
Thank you very much, Thomas. Questions? Yeah, the mic is going there.
Hi. With these AI models doing predictions that can be accurate or not, do you think these models will be able to then predict how likely they are to be accurate for specific chemicals? Like, will they know their own certainty? So you could say, oh, we're 100%, this is right. This one, 60-40, that kind of.
This is actually exactly what these models can do. Typically, AI is not outputting this, but it learns from every pattern for a given substance how certain this is now. And I think this is a godsend, because it makes a tremendous difference. You will not achieve 100%, but it makes a big difference whether the AI says, this is more or less a toss of a coin, or it is something where we are very sure. And over time, we will learn how much we can trust these things. And it will then also make a tremendous difference for the use cases. I mean, if you have a 10% probability that something is a carcinogen, you might still consider it for a household cleaner, but not for baby food. And so it is. I think this is really an important piece of information which we can output as an integration of all we know.
Thank you. Other questions? Here.
So you showed a lot of very impressive work on accuracy in predicting these chemical properties. I wonder if you've looked at explanations for the predictions and whether human risk assessors or other stakeholders accepted them or just had to go on the output of the model.
Yeah, I mean, this is touching on a very important point of the shortcomings of AI. Explainable AI is at the moment under enormous development pressures, and there's more and more of it coming. But the explainable methodologies are inferior to the non-explainable ones. In our 2018 work, we used random forest, which is an explainable type of AI, and we looked into the 74 properties, what is predicting what was the most influential variable. And this is part of the appendix we published. And 24 of the properties did not really contribute anything to the predictions, but there were a lot of very logical things, like eye irritation was very much predicted by skin corrosion. And I thought, while this is very simple, but I was very happy to see it. Or mutagenicity was a driver for eye irritation, which also makes sense because it indicates reactive chemistry, and reactive chemistry is more likely to do something. So here there was some face validity. For the more modern type of approaches of deep learning, there is approaches, but they are very laborious type of sensitivity analysis, which you can do retrospect, and but we're on it. It's coming. You always have to think how young these methods all are. We are talking really about incredible developments over the last 5 years or so. I'm impressed how far we are already. So better brace for it.
Thank you. One more question, yeah, and then on the back, yeah.
I mean, I agree with you that it's extremely impressive. I studied AI 20 years ago, and we would have thought this was impossible, right? I mean, neural networks were something cute you did in Excel sheets, but not a tool to actually unlock this much knowledge. But I guess my question about explainability wasn't really about explainability of the method, but of the result. Like, you might even get a big LLM to tell you, well, I think this because the chemical structure is similar to that, or because of these studies on a related compound. I mean, more that kind, not insight into the model, but insight into the reason that a prediction is being made.
Yeah. So the Tom Lichtefeld, who is doing a lot of the programming of this, he has created a report format, TOX index for our AI, which we are now bringing to this Copilot, which gives you the most influential substances, which gave most of the information, so you can see essentially the read across which is taking place, and this gives again a lot of face validity to this. Knowing, yeah, it picked some substances which are relevant or not, yeah. But it is very difficult to exactly quantify how much what contributed, because AI is using these complex patterns and is not only using the strong associations, but also many, many weak associations. It is really shining because we have so much input data, and sometimes even things which are not incredibly strong on their own suddenly add a little bit to make the prediction better. Yeah.
Thank you. I think we will have a session today on explainable AI, so hopefully we will be more clever by the end of this. But this is one of the fundamental questions: will we have a mechanistic understanding of why something happens? Yeah, there's a question back there. Pass, please.
Thank you. I'll keep it short. I would like to debunk a little bit the sentiment that explainable AI is not necessarily as good as full-fledged AI. It is true, of course, for random forest and those kind of things, but there is a lot of work going on baking the explanations into the model, so really model-based explanations. I always compare it to the lifetime of a person, and it's maybe a baby toddler at best. So I agree with you, that's a very new field. But I do have good hopes that we are getting there. At least I'm more of an image analysis guy, so at least there we're getting there. I don't know that much about the exposome or those kind of things.
Yeah, no, I'm with you. I have, for the purpose of this lecture, certainly simplified many things to get some messages and trends across. I'm absolutely with you. The explainable AI is one of the hottest areas of research, because everybody wants to get out of the hallucinations, wants to get out of the wrong results and make it credible. And there's a lot happening in this field. But at the moment, the large big models, they don't have this embedded, what is easily accessible. But this will come. I'm with you.
Thank you very much. Thank you, Thomas. I think we have to move on to keep our schedule. So thank you once more, Thomas, for being with us. Take care, and see you soon. Thanks.
So, bye-bye, everyone.
And now for the next speaker, I would like to invite to the stage Professor Luis Paulo Reis from the University of Porto. Specializing in artificial intelligence and robotics, he is known for contributions to autonomous systems and their applications in various fields, enhancing the intersection of technology and society. Paulo, the floor is yours.
Okay, thank you very much. So, thanks for the invitation. I will speak a little bit about AI opportunities and challenges, mostly in public administration and food safety. This is the agenda of the talk. And I believe we are getting into a new world, in the discovery of a new world in which AI is no more a tool, but it's a kind of partner with different capabilities and with whom we can solve very complex problems together. AI, as you know, comes from intelligence, the capacity to solve new problems through the use of knowledge, and it's the science that is concerned with building these intelligent machines that solve problems or perform tasks that, when performed by humans, require intelligence. And if some years ago we had what we call weak AI that can solve only narrow problems like playing a game of chess or getting the best way in a map to go from Parma to Rome, we are getting to a point in which we are arriving to strong AI that can really solve any kind of intellectual task that the human also can solve. This was more or less science fiction a few years ago, but is getting into reality. AI started in the 50s with the Turing test, and then with the first chatbot, for example, Eliza. At the time, with logic, people thought that could solve anything. And in 1997, after a winter of AI, a chess program could beat Garry Kasparov at the time. Kasparov didn't believe that he lost against AI. He thought, okay, there should be a bunch of grandmasters playing against me. But in fact, we can now do a program that can beat any of us in 10 minutes using this computer in a very easy way. Then robots, then the first assistants, and then it was already talked AlphaGo, then AlphaGo Zero, then AlphaZero from DeepMind. The idea that a machine can learn only playing with itself without seeing any human to play a game of Go, that is a Milner game, and create a new way to play Go. And the champion of Go at the time that lost against a machine and now loses 1-0 against AlphaGo Zero said, okay, I will not play any more Go because this machine just invented a new way to play Go. I cannot understand how the machine plays, but in fact, it plays a lot better than me. And if a machine can get new solutions to solve problems that humans study for more than 1,000 years, it can get new solutions to surgeries, to creating new medicines, to solve very complex problems that humans solve. And if the timeline of AI was in years, in 2021 was in months, and now is in days or in minutes, new applications, new algorithms getting. Due to the power of machine learning, the idea that this is a field of artificial intelligence that make computer systems have the ability to learn. That is to progressively improve their performance on a specific task from data, supervised learning, or even from the results of their actions, the reinforcement learning, without being explicitly programmed. From the basic type of machine learning, supervised learning, which with large amount of data, we create models that, for example, can get if an email is spam or not spam. We arrive to a new type of machine learning that can have huge development in future, reinforcement learning, in which a machine observes the environment, selects an action using an action policy that gives only the probabilities of executing the available actions, and typically random at the beginning, executes a sequence of actions, and then gets rewards or penalties, and can change, update in a learning step, update its policy until it gets the optimal policy using one of the thousands of reinforcement learning algorithms. And we're getting to a point in which we have deep learning. Deep learning already exists for many years, but in 2010 and until now, it has huge development. It was already said due to the amount of data, to the development of hardware, but also to machine learning frameworks. We can now solve a problem in just 3 lines of code, which makes everybody an AI expert. We can just say to the machine to get this data, then to get this model to predict this variable, and at the end to give all these graphics to the user. And this makes a very interesting thing, that is we believe that AI will replace, AI and robotics, lots of jobs, but the first job to be replaced is the job of programmer. In fact, now programming is made by the machine in a very easy way. We just say the input that we have, we describe the output or the program we want, and the machine just creates or learns the program. Which makes or creates the end of programming. Like the NVIDIA CEO predicted, and even using StarCoder, for example, we can embed the programmer into a computer without any need for the internet, and we just have a computer that is a programmer, and that programs a lot better than most of the professional programmers. And even software engineering. People are now predicting the end of software engineering with the new AIs that are software engineering. And in fact, the salaries already declined across board for software engineering a lot. Obviously, due to the power of generative AI, with generative AI, we can not only create text, but we can create images, we can create videos, audio, even 3D models, and recently with large behavioral models, we can create just behaviors or actions that solve problems, for example, to be used by robots. Learning patterns from existing knowledge, and really using very large neural networks to store those patterns, enabling us to create or to be able to do anything with the data stored. It's impressive the way that generative AI during the last few years has evolved, and the market size projections continue to show that it will evolve exponentially in the next few years. This by the power of artificial neural networks. We use neural networks for many, many years. I already used neural networks when I was finishing my degree in 1991. But these deep neural networks that we can grow to any kind of size, and we can use in the different way that we use neural networks, natural neural networks, have the power really to store vast amounts of information and to be able to predict or do anything from the data available. The market is really very interesting with competition for ChatGPT, with Gemini, for example, from Google. Even startups, for example, Anthropic has Claude 3.5, that is one of the best AI systems at the moment. And in China, with Baidu creating, for example, the Ernie bot. We already used we already use AI for many years. For example, Google search is filled with AI in its algorithms just to understand what we want, what information we want from our simple search. And as Google, for example, Bing, with this kind of interactive way of searching information. In the area of programming, we have now new systems in which, for example, with GitHub Copilot, we can just say what we want with voice support, and the AI creates the programs for us. Or even, for example, more complex programmers like AlphaCode from DeepMind that can compete with the best programmers in programming competitions, for example, with excellent results. In China, we are seeing huge development from AI. For example, Ernie bot. And what we see in China is that they have obviously lots of data. They don't have any data protection. China obviously is an autocracy, so they can do huge projects on the fly to adapt to the changes. And Europe has to be very careful with this, not to lose this AI battle to China. The interaction of this system is also changing. If we interact initially by text, then by voice, now we can interact in a multimodal way. That is, we can interact by gestures, we can interact really like we interact with a human. New systems are appearing with multimodal interaction and multimodal and everything multimodal. Startups are also very active. Claude is a very interesting example. If you didn't test this system, is really amazing. And also big companies. Now with Copilot, we can automate a lot the way we create text together with AI, the way we create or analyze data with Excel and with all the power of AI, create presentations and everything. We already used AI for many years, for example, with applications like Grammarly for grammar correction. For example, DeepL, the best translator around that translates perfectly tests and was one of the first to use the Transformers model that give rise to this generative AI. Or even Quillbot, for example, what my students call anti-plagiarism tool, because it's a paraphrasing tool in which basically it writes in a different way, but keeping the same idea in the original text. In the area of images, we have lots of systems, like, for example, DALL-E 3 that creates new images from simple prompts. And one of the most amazing developments is the way that we can now change these systems to our own needs. Explore GPTs, for example, we can have GPTs that combine instructions, but with extra knowledge. And, for example, create GPTs for creating websites, for example, for creating cooking recipes, for example, creating science. And in science, applications like Illicit, for example, or Consensus, enables us to just ask a research question and you can get all the papers, and we even can get the papers compared with tables showing the algorithms that were used, the data that was used, the results that were achieved, and it really speeds up a lot the process of doing science. I believe the most interesting development in the last few years is the rise of these short, low-cost, open-source models. Llama from Meta, for example, or Mistral, or the lightweight model from Gemini, that is Gemma. These models can be embedded in simple computers, even can be embedded in mobile phones, the smaller ones, and with competitive power to the large language models. There are lots of comparisons between all the players in the market. Claude, GPT-4, and Gemini are obviously the best one in most of the tasks. But if we go now to the chatbot arena, this chatbot arena is an arena that compares all the AI applications with various tests. And what happens is that obviously the GPT-4o, Claude 3.5, and Gemini are at the top, but we can see non-proprietary open source models appearing with an halo very similar to the top models. halo is more or less like in chess, the halo of the players, and really very competitive. So we can now use models that we can embed on our computers, which is very interesting for the future applications. And should we adapt or resist to this? Obviously, we have to adapt because technology is unstoppable. I remember, I like the example of the mobile phone. This was the guy that took all the jobs from those guys, okay? The calculator, the radio, the camera, the alarm clock, the phone, everything disappeared because of the new technology. And there will be lots of things that will be disappearing because of AI. Not only devices, but also processes that will be completely changed in the future. In technology, really, I like the Dunning-Kruger effect that is typical from technology. People typically tend to, very fast, without any competence on the use of technology, have lots of confidence on the technology and go to the peak of Mount Stupid. And also very fastly go to the valley of despair in which, okay, this AI doesn't do this. Okay, the AI gives me false information, obviously because this generative AI generates things. It doesn't search for things. And only with lots of competence and a lot of time after we go to the plateau of stability, sustainability in which we have the same confidence, but then we are masters in the technology. The AI models now have a huge bunch of techniques to improve the way that we can use the AI. For example, the retrieval augmented generation is a very powerful technique for improving the large language models. Instead of just prompting the model and getting an answer, we can just prompt the model. Then we have a kind of semantic search in which we get lots of contextual data. From encyclopedias, from all the data that we have on our organization. And only after that, we get all the things to the large language model to get an answer. And this works quite better than just using directly the large language model. And there are lots of other ways of adapting large language models, from fine-tuning to LoRa, for example, to knowledge distillation. Lots and lots of ways are being used around. I would like to emphasize on the last two. Reinforcement learning, that is the idea that we can improve the model interacting with people or interacting with the environment and improve the way it solves the problems. And in a continuous learning process, throughout the time, improving and improving and continuously improving the pre-trained model. And this enables us to get to what is now called auto-GPTs. The idea that instead of just interacting with the AI, we can give a task, a long-term task to the AI, like organizing a wedding or organizing a conference, and then the AI proactively solves the problem, interacting with us, interacting with websites, interacting with other people. We now have already very good systems for AutoGPT and for using this for long tasks. And in 2024, there were lots of key issues in large language models and in the use of AI. I would like to emphasize that open source will really become the de facto way for using these large language models. We have now lightweight open source models that we can embed, that we can use on our data without getting the data out of our computer, of our server at our organization. And this enables even small companies to start using AI now. And there will be also a shift towards valuing data. Data, not the large language models, becomes really the true competitive advantage, for sure. This was already told yesterday on the talk. And we'll have large language models not only for people, but for machines and for robotics. In terms of AI opportunities, I listed here lots of them. Obviously, data-driven decision-making, automation, predictive analytics, explainable AI, it was already talked, collaborative learning, regulatory compliance, and also a large number of challenges. We already talked in this symposium about data readiness and quality, the need to have high quality and standardized data, and privacy ethical concerns, explainability. One big concern is the integration with existing systems. In fact, organizations lack infrastructure to fully integrate these AI solutions. And we also need not only technology, but staff training and process adaptation to adapt our processes to solve the problems using the power of AI instead of solving them in a traditional way. In Portugal, we have been developing several projects together with the public administration. These are some examples of what we have been doing with AI and public administration. Together with our Food and Economic Security Agency, ASAI, we developed a very interesting system for risk analysis and the selection of economic agents to be supervised. Based on AI, we start by georeferencing all the information and also do a web scraping process so that we could get all the data from the 3 million of economical operations that we have in Portugal, and develop a system using natural language processing for all the complaint analysis and their automatic classification. And finally, we use optimization to create optimized and flexible routes for the inspectors. We then, in the second project, improve the system to be in real time, creating a real-time virtual inspection office with disruption management so that we can track the inspectors and change in real time their routes. And with also a very interesting system for smart forms with filling assistant, in which you can fill in the inspection forms, create new forms, and fill in the inspection forms, but already with AI working to fill all the information, for example, the localization and lots of other information concerning the inspection. We also, with our health regulatory agency, we improve this concept and create a new system also for electronic complaints analysis. But here with the new focus, creating a system that even analyzes duplicated and mostly related complaints. So that instead of giving the complaint and the analysis of that complaint to the expert, we can give the whole process with all related information so that it may be analyzed as a whole. We then improve this to a complete risk-based supervision systems in which we can use flexible risk matrices together with all the information received by the establishments, and this now is being fully used at our health regulatory agency in Portugal. I would like to finish by getting here a small vision about how will be AI in the next few years. I remember seeing this movie that most of you should know, Star Wars. I was 7 at the time, in 1977. And this vision of C-3PO and the robot that knows everything and can solve anything is coming really to very close. If you think about advancements in robotics in the last few years, we have drones, we have robots that explore planets, exoskeletons. We even have cooking robots, really cooking robots that really cook on the kitchen. We have robots that can imitate human faces. We have robots that can imitate humans dancing. Robots that can run and play with children. And really, the power of robotics is coming to a point in which even, for example, this Atlas robot from Boston Dynamics that has been already discontinued, and robots from Tesla and other robots from Boston Dynamics and for many companies have abilities very close to humans, even in manipulation of objects, in the way they can do things. And they can learn using reinforcement learning. We can now create a robot that has an embedded large language model, in fact, a large behavior model in which you can just create solutions using behaviors and actions. Then we can embed the model in a computer. We can embed the computer inside of the robot, and then the robot can learn using deep reinforcement learning, interacting with the environment. And this certainly will be the future. We already have this kind of robots, for example, AMCA, that can interact using a GPT model, talking in a very interesting way with humans, and that can learn using deep reinforcement learning. Deep reinforcement learning will just have the big neural network that was already pre-trained, and then we can retrain the neural network, improving successfully the way it solves any kind of problem. And the power of this is huge in the next few years. Just some simple examples. We work a lot with robotic soccer, football with robots. Okay, it's a very nice application of AI and reinforcement learning. And for example, we could put robots that only walked just running 3 times the speed, because deep reinforcement learning, again, can find new solutions for problems, solutions that we don't know, we didn't know that they existed, but making robots that are the same seem almost Supermans. This is our robots playing against the other team, and our robots seem Supermans while the others, okay, are using normal robotics. And it can learn anything. For example, we tried to put the robot learning to dribble, and it could learn this kind of dribble. Here you see the slow motion, in which we control perfectly the ball. And at a given time, we can put the robot dribbling. Now he's dribbling the ball, and just dribbling all the opponent team, because he's faster in this dribbling than the others walk. It can just go around them, and it's impossible for them to get the robot. So we are 3 champions of this RoboCup competition, because really our robots are more or less unstoppable. So the power of deep reinforcement learning is really huge in any kind of application, and will be the future of AI. So just short conclusions. AI offers really huge potential in the areas of public administration and food safety. That's the main conclusion. And the way we interact with AI will change a lot. We will have this new generation of AI-powered and deep reinforcement learning-powered robots that will be more or less the future of how we will interact with AI. Okay, thank you very much.
Thank you very much. Questions? Yeah, everyone is shocked by the Portuguese robotic football team.
Thank you very much. I'm really surprised with the velocity with these challenges with AI. But just one question with Paul. Why the AI don't detect that as it's not food security and it is food safety?
Thank you.
Probably I didn't put the slides on AI, but but security and safety are more or less synonyms. Not completely, but
not in this community. Yeah, thank you. Yeah, please go ahead.
Hi, and thank you. So I have a question based on a comment you made, and the comment was that we in the EU are at risk of losing the battle against China, because let's call it maybe the way we want to make our systems safe. We want to protect data, or privacy themes. Are we at the risk of losing the battle against, let's say, China, the US, and what could we do? Just a simple question in the morning. Thank you.
Just a simple answer. I think sometimes we regulate too much things that we don't completely fully understand. The way, for example, the EU Act, the way we regulate, for example, robotics, we are regulating for autonomous vehicles, for simple vehicles, and for simple industrial robots. We are not thinking about this kind of robots that will take care of our child, that will take care of our elder in the future. And basically is a regulation a little bit for what existed in the past. Even for large language models, nothing about large behavior models that are a lot more dangerous, nothing. Okay, so I like a lot much, I like certification in general when we have a product, certify the product. And China doesn't regulate much. And that's a huge problem because they have all the data. They collect data anywhere without any permission, as you know, and they have powerful and big computers managed by the states, and really is a lot dangerous. The way AI is evolving, we need to be competitive. For example, I'm evaluating now proposals for Horizon Europe, the call that just finished it, and we have 130 proposals for 7.5 million. And we'll get 2 proposals approved because the budget is 15 million. Okay, that's not the way to win this AI battle.
Yeah, thank you very much. Thank you. Question, there is a question in the back. 2 questions.
Yeah, hello. Thanks, Luis. The morning session, really insight, seeing the whole history of the AI. Yeah, I will not go in the battle of this, that data collection, because we did the same here. We let the 5 big company to collect all our data without any control. So that happened here as well. And we have to learn that. I'm going more on the part of this, the explanation part of the AI, that how you can explain that. And I want your insight, because we are talking that we want to have, and we have some technology as well that we are doing that, like the Lime, that we can explain some of these model. But as we go more in the regenerative or the more the deep part of the AI, often that's become very complex to explain. How do you explain that? How we can do that?
Well, in fact, the approach with large language models even has more power to create explanations even with the same model, because in fact the model may explain how it gets to that conclusion, how it gets to that solution. But there are things that are not explainable, for sure. Imagine, for example, Alpha Go Zero playing Go. It cannot explain how it plays Go. And if it could explain, probably we will not understand, we humans. And so there are solutions that, okay, just work. They are excellent solutions. They are a lot better than the solutions created by humans, but are not explainable. The Go example is really a very good example of a thing that is not explainable.
Thank you. One last question, and we have to move on. Yeah.
Thank you very much. Fantastic presentation. I'm very much a pro AI person, but I will at least do one very personal comment on your last note on childcare and elderly care. It took us 15 years of social media to finally understand that in schools, mobile phones should not be allowed because of the impact they have of young children. So a lot to think about in this context. What I'm more interested in your thoughts about overfitting and the risks, in particular in the interaction with robotics and humans. And I focus specifically on the fact that in the specs of GPT-4 published by OpenAI in the categories of risk, one new emerging risk that they pointed out to themselves was the interactions with other technology or other tools, which we of course now see. So what do you think is then the reliability and robustness, in particular in more dangerous interactions?
Yeah, that's a very good question. In fact, we need robots to take care of our elderly because the population is getting older and the life expectancy is increasing. But in what concerns overfitting and in what concerns really the AI learning with the environment, we have lots of dangers. Because this new, for example, large behavior models, we have now models that are being trained with 40 types of robots in 30 different research labs and universities, together with Google DeepMind and other companies, and that are learning to do, creating a general model to do any kind of task, from picking up an apple and giving it to a person to filling a cup of water. And the interesting idea is that these models may be trained not with one robot, but with all kinds of robots around, and create a global large language model, or in this case, a large behavioral model that works on all robots. But your question is very good, because deep reinforcement learning then has the power to improve that model, for example, for the robot that is at your place. But it has lots of dangers. Dangers that we don't yet know what they are, so we cannot regulate that yet. But that obviously will be analyzed in the future. So this area of robotics, I think, is an area that has huge risks, but also has huge capabilities. Because, for example, with autonomous driving, we can put 5 times the number of cars using the same infrastructure. Okay, that's excellent. Okay, obviously it has risks, but at the point we'll have autonomous cars that basically are better drivers than any human, and even I believe that humans will be forbidden then to drive in certain areas of cities, because that will be a lot more efficient, and humans will be dangerous on those areas driving together with autonomous vehicles.
Thank you. That's personally, I don't like this idea. Well, no.
My older child also don't like. When she heard, "Oh, I will not be able to drive," she started crying compulsively. Okay,
yeah, thank you. Thank you very much, and thank you. I would like to welcome our next presenter, Thomas Margoni, a research professor of intellectual property law at the University of Leuven. His research focuses on the interplay between law and technology, particularly copyright law, impact of AI and data governance on information creation and distribution. So we already started to touch on that. Thomas, please, the floor is yours.
Thank you very much. First of all, of course, thank you to the organizer for the invitation and for having me here. It's a great pleasure to come back to Parma and to EFSA. Is always a great and very stimulating environment. So thank you for that, and also to allow me to learn how the laws that I study and that I contribute to a certain degree to interpret or to develop impact on the activities of actual people before we are fully replaced by robots. So that's for me what I want to say. It's very helpful also because a part of what I'm trying to contribute to the discussion is what I learned from it. So I adapted slightly my slides, introducing some basic features, but I'm sure that most of you are aware of that. I think, however, this will be helpful to introduce and to lead to my analysis today. So the broader framework is the laws, the legislative landscape that applies to AI at least in the EU. And some of these elements emerged, but I think one of the main points that we have to keep in mind is that we have new laws, such as the AI Act, that have been specifically developed to regulate AI or certain features of AI. But we have many, so to speak, old laws that I will not discuss in depth today, but I will give you an example of an interaction between a new and an old law that were developed to regulate human behaviors and which to, often a very large extent still apply to AI, enhanced or based or related activities. And therefore we find ourselves in this, from the legal scientist point of view, extremely exciting moment where we have to determine whether and how these interactions plays out in a way that then has a practical impact, for example, on applying AI tools to your daily activities to determine whether a product is safe or secure, for example. This is not trivial activity. It's something that, as I said, if you're a legal scientist, is exciting, but if you're a person who just wanted to know, okay, can I do this or not, then it can become extremely frustrating. And also because of the recency of some of this legislation, the AI Act just entered into force, and it will it has a a windowing system, so different parts of the AI Act will be applicable. So the AI Act is already into force, but many of its regulations and rules and articles are not applicable as of yet. Some are, but there is a windowing system of 24 months within which they will become applicable, but the law is already there. So despite being extremely new, some of its rules, some of its provisions already apply in practice, and we need, of course, to know how this will happen. The general framework of the AI Act, just to give you a very broad overview, is to subdivide. So first of all, the AI Act is a product safety regulation. So I think that under this point of view, it may be much closer to your daily activity than to mine. I'm an expert in copyright law. So the field of laws here are very different. Product safety and private law, copyright law are quite distant. And it is a product safety type of legislation that identifies 4 or 5 main areas of risk and attach to each of these areas of risk different obligations. The 4 main type of risk are an acceptable risk, and this means that that type of AI is forbidden. And here you have, exploitation of vulnerability of persons, manipulation of user behavior. So all this AI, it's forbidden already in the EU. So you cannot do that. If you do it, stop. This is intended to be a relatively small category. Then there are the 2 main categories, or at least most relevant categories, which are the higher risk type of AI, which is allowed, but there are a number of requirements regarding risk management, data governance, which was mentioned yesterday, human oversight, etc., that needs to be implemented by the AI developer. There is the category of limited risk, which is an interesting category. It was added ex post, so it wasn't present in the original proposal. So some of you might ask, well, why it's limited risk transparency, not part of AI risk? Good question. It was debated whether it could have gone in there. For some reasons, it was decided not to. But to be clear, limited risk is what the AI Act now calls general purpose AI, which are the generative systems that we often talk about. So LLMs usually are limited risk. It doesn't mean they cannot also be higher risk depending on the field of activity where they are applied to. In the case of limited risk, there are a different set of rules that needs to be met by the AI provider. They mainly focus on transparency. And here, particularly also from the talk that we heard earlier today from Thomas, but also from yours, we know that we need to train on a lot of data. From the legal point of view, this data may be different legal categories. It may be journal articles, probably protected by copyright. It may be images or videos, probably protected by copyright. These text or images could contain personal data, probably protected by personal data legislation, etc., etc. There may be many of these regulations. This limited risk requires the AI provider to create some measures, one of these being a summary that needs to be made publicly available to disclose to a certain degree, and the degree to which this disclosure needs to reach is object of discussion, in order to allow transparency. The word of the AI Act is to allow parties with legitimate interest to exercise their rights. And then there is the final category of minimal risk, or the AIs that should not pose any risk. And in this case, we have very, very close to no additional legal requirements. But I think that the 2 most relevant are higher risk and limited risk, particularly for the conversations that we had yesterday and this morning. My feeling, even though it would be necessary to have a case-by-case assessment of whether that AI system or that large language model, how it has been developed, what does it do, and how it is being deployed, most of the time I would assume they fit in either or both of these two categories. And then there is the issue of data, right? Because with AI, as we have heard very well, we have a technology that is new, that is powerful, that is surprising, but is also a technology that relies massively on data. Without data, the type of AI, of machine learning-based AI that we find so exciting, I would imagine probably not exist or be impossible. And we have to keep in mind that in the EU, but also in many other countries, right, there is this view that the US or China do not have, laws. They are different. There are laws that protect copyright, that protect data, personal data, that protect other type of rights. I think I was one of the only ones, Tucker, who yesterday understood the foible reference or expression. They do apply, but we have to understand that there is a whole taxonomy also from a legal point of view of data types. And particularly recent EU legislation has developed in a sense conscious of the need to unlock the value, I think the expression is, of data in the EU. A lot of legislation, some of which is listed here, was passed in order to either make mandatory or incentivize or make it more desirable under a marketed point of view, the disclosure and the reuse of data. This includes a lot of, so to speak, public sector data. We have categories that are already legislated, such as high-value data sets, so the data sets by national meteorological offices or national statistical offices. In the EU, they have to be made available and reusable, both technically and legally. We have the category of research data, that is data developed with so not publications, but the data supporting the publications. Article 10 of the Open Data Directive make them already since 4 years basically open access by default, and that's an area where there is a lot of non-awareness. But of course, this data may represent a phenomenal amount of knowledge that can be used for training algorithms. I don't want to go through all of them also because I don't have the time, but we have non-public sector data regulated in the DGA, we have IoT data, we have copyright, personal data, unfair contractual terms, and then all the vertical legislation that may apply to specific subtype of data, such as agricultural data, food data, etc., etc. So this is a very complex map in its own right and needs to be properly unpacked in order to understand, if you want to comply with the laws, including the AI Act, what can be done with the data that you have. I also have a reference that I added yesterday to regulatory sandboxes, because this is one of the innovations that the AI Act introduces in order to favor the development of, well, in theory, the ambition of the AI Act is to favor an innovative regulatory framework where new type of activities can be tested with limited legal liability. So in the few minutes that I have left, I want to focus on copyright because it's the area that, first of all, I know best, is where I really work on a daily basis. But I also think it's quite relevant in many situations, both if we are talking about papers, if we talk about scientific papers. Most of them, I cannot think of one that is not copyright protected unless it was entirely generated by AI, of course, but also because a lot of the databases that often are used where the document itself is not protected by copyright, but its aggregation and its structuring in a database may trigger both copyright and another related right to copyright called sui generis database right that we do have only Europe and not abroad, and that's one of the problem on regulatory competitiveness. So this is, I try to be as little lawyerish as I can, so I use colors and diagrams. But you have to forgive me, I'm still a lawyer, so it is what it is. But this is a representation of that I've developed over a few months of what are the legally relevant steps in AI or in machine learning based AI. It is an oversimplification, and a lot of my computer science friends, point out, oh, you're putting together categories that are very different, but these are filtered through the need to determine which one what is the correct legal qualification from a copyright, mainly copyright point of view, but also other rights. And you have the relevant steps, so the acquisition of data, the preparation and the training, the model, the resulting model, the inputs, the prompt that the user gives to the model, and then the output. And here you have the legal barriers. And from a copyright point of view, it's mainly an issue of the right of reproduction, so making copies. Particularly under EU law, and that's another element, the details are important. Where US law and to a certain degree Chinese law are much more competitive, a lot of things that under EU law from a copyright point of view are considered a reproduction and therefore requires authorizations are not considered a reproduction under other laws, non-European laws, and therefore in that case you could proceed without the need to secure an authorization. In all these cases, we need an authorization and we need access. So the red dots are, let's say, the legal barriers, and the green boxes are what we would need in order to excuse those activities. The reality is that, a small clarifications. We treat the output in the same way, but the truth is that there is an ongoing debate about whether the output of text and data mining connected to the text and data mining exceptions in copyright and the output of generative AI regulated by the AI Act are the same thing. The AI Act has clarified that at least to a certain degree, the text and data mining exceptions cover generative AI, but there are situations where this assumption may not be correct. This is where we are right now. It's an ongoing debate. I don't enter into the detail, but it's just a way to give you a flavor of how complicated and hyper-specialized the conversation can get. To be very quick, so this is the situation. We treat outputs together, and then we have the exceptions that allows us to proceed, and we have quite a few of them. We have temporary copies that certainly apply to TDM. I argue also to generative AI, but it is under debate. We have the Article 3 and 4 TDM exceptions that were specifically devised for text and data mining and may or may not, certainly apply also to generative AI. We have the old research and teaching exception, which was relevant at some point, particularly in the past, but remains there. And we have the issue of what are these reproductions and adaptations. So the generative AI model, what does it produces? Because if it produces, that was what I obtained when I looked on, I think it was Google or DuckDuck.go, which DuckDuckGo.com, which is what you should use if you care about your personal data, of course. Give me a representation, a mathematical representation of the output of a generative AI model, something like that. This is not a copy. These are data points, right? So should we regulate these through copyright? And I think that most copyright scholars will tell you, well, no, of course not. This is information. These are patterns. This is knowledge discovery. This should not be regulated. But at the same time, these, I'm not sure if in this specific case, pass through the filter or the brain of the artificial machine leads to this one. And this is taken from the litigation pending in the US on Getty images. And is this a copyright infringement? And in this case, of course, it becomes much more clear that there is a degree of similarity, and there could be copying, or perhaps not. It's simply learning. Probably this is very bad learning. I think this might be a case of overfitting, but I'm looking at my co-presenter just to make sure I use the correct expressions. But there are many other cases. What happens if you ask, the ChatGPT to make a perfect copy of Mickey Mouse? It tells you that that would be a copyright infringement, but I explain you how to do it yourself. Are you avoiding copyright infringement here? Are you, joint tortfeasor because I'm not doing it, but I'm enabling you how to do it. And is the small copy here made with DALL-E, is that an infringement? Because, we would recognize Mickey Mouse there, but there are also certain differences in the proportions and in the shape. So the prompt there was, draw me a Mickey Mouse that is not copyright infringing, right? So all these things are, or again, another good example is to ask ChatGPT, again, but could be any other model, to write a story in the style of an author, right? So can you write a novel employing a J.K. Rowling style? Is that a copyright infringement? How similar needs it to be in order to be infringing? And what if we substitute a famous author with, I don't know, the profile risk that is typical of EFSA? How does it impact the results and the risk profile, both in terms of copyright, but also of many other laws, in terms of, I could imagine, but I'm exiting my field of expertise, that different food agencies might apply the same parameter or different parameters in different ways. One may be more conservative, one may be more open to innovation. And what is the risk of adopting or asking the AI to adopt one of these styles? So again, here I just want to give you, not to explain you the law, it would be very complicated even for law students or experts, but to give you an idea of how complex the situation is for just one of the laws that we have seen. So, of course, we have Article 4, which in the EU allows to perform text and data mining and therefore to train the models if the right holder has not opted out. And therefore, we have to introduce the issue of how to opt out and how to make it machine readable. And the old models were the robot TXT that we have for search engines. And then we have the issue of lawful access. So the fact that all these exceptions, or at least most of them, are available to you only if you have lawful access to the original training material, and what this lawful access concept means, because of course, as you may expect, is not defined in the law. And this is where I am working right now. And then we have the additional introductions of the AI Act that for the GPI requires GPI model developers and providers to draw up and make publicly available a sufficiently detailed summary, slightly oxymoric, of training data for GPI and to develop a copyright policy that complies with EU copyright law. So a lot of attention on copyright. There is this perception that particular generative model may threaten, may substitute not only engineers and the computer scientists but also authors that, screen literary authors or authors of TV programs or of music can be substituted by AI. And then, of course, on top of all of this, there is all the data and digital legislation that I mentioned to you, and that has a role in playing in this complex emerging matrix. And then, of course, there are the latest development, or the idea, that's another area where I'm working on, to try to synthesize all this complexity through the legal but also policy and regulatory development of common European data spaces, which, especially if you're European, you might have heard of them, is an ambition of the past and the current Commission to reach a sort of data union where data, particularly non-personal data, can flow freely across the borders, both legally but also in terms of infrastructure, interoperability, etc., etc. So this paints a very complex picture. I have a couple of examples of lawful access and of opt-outs that I will not discuss in detail because my watch already beeped. But there is one element that I want to point out. So I call it speciality, which doesn't sound very good, but because I was going through temporality and all the other categories, then that follows logically. The AI Act, in general, but also specifically for the field of copyright, says that providers have to comply with this legislation regardless of the jurisdiction in which the copyright relevant acts underpinning the training of those general purpose AI models take place. It means that if US AI developers, Chinese AI developers, Australian AI developers, you pick it, want to make that model available in the EU, they have to comply with EU law. So ChatGPT or OpenAI training their models in the US have to comply with EU law, not with US law. And that, from a copyright point of view, is a huge development, because we never had that in the field. It is more logical if you look at this from a product safety point of view. If you want to put your product in the EU, it has to be safe. And the way of looking at this is to say, okay, it is only safe if it complies with our laws, including copyright and data protection. And this is a way, going back to your example, the competition and the regulatory competition that we have outside Europe, this is a way to try to mitigate that, to say, okay, you can do whatever you want in country X, or maybe more, or maybe in a different way, but if you want to enter our market, you have to make sure that whatever you put in our market has been developed following our rules, right? And that the ambition is that because we are a bigger market, we are big enough. I think it would be unlikely that OpenAI develops two models, one for the world and one for Europe. So to create some sort of Brussels effect, I think it's called, we have that in the field of data protection, where the regulatory standard becomes more and more the European one. So this is, I want to tell you, and the last thing is and I promise it's the last one, it's the current work of the AI office in this field, which I think is very important. And it is open to multi-stakeholder consultations, even though I may be wrong, but if someone of you is interested, you should look Multi-Stakeholder Consultation AI Act. It may still be open for you to sign up. There are different working groups that collaborate with the AI office in order to develop these codes of practice, and therefore to influence what would become, if the process is successful, a sort of implementing act of the AI Act, so a specification of how these rules will move from general and abstract to applicable to certain situations. Full disclosures, I am advising the AI office in this, but I think that the most represented categories there are copyright right holders and AI developers. I don't know if there are people from EFSA or in general from regulatory authorities participating, but that would be an important venue, perhaps even for the data group, the data and AI group, to try to influence a bit the kind of ongoing conversation at the regulatory level. With this, I conclude, and I leave you with a very self-referential list of citations in case you are interested in discovering a bit more of this world. And thank you very much for your attention.
Thank you. Thank you very much. Thank you for the presentation. Questions, please? Yeah.
Thank you very much, Akash. So a question then about kind of that spatial compliance. Are there any LLMs at the moment that are spatially compliant? Are they're expected to be in the next 24 months?
Yeah.
Okay.
So the way in which it works for the part on Article 50 to, I think it's 56, is that, so the part that is covered by the codes of practice, the codes of practice have to be ready by May. The Commission or the AI office has time, I believe, until September to decide whether to adopt them or not. And if they don't adopt them, they can intervene with the delegated act. Whatever is the final result, that will become compliance with that standard will become a presumption of compliance with the AI Act. So if you as a GPI provider have a corporate policy and a summary that comply with the templates given by the AI Act, then there is a presumption that you are compliant, which in legal terms means that is the other party that should prove that whatever the cause of litigation is not complying with that provision, has nonetheless created a damage. In the field of AI, what you need to prove has often been seen as the main problem. It depends in which field we are litigating, but usually you need to prove that a right has been infringed. And for some rights, the proof is really difficult to achieve.
Right.
So the switch of the burden of proof may be particularly effective in this situation. At least this is the working hypothesis.
Okay, the reason that I do ask is, I could see a potential future where the likes of OpenAI is willing to pull out of Europe because of the massive exposure to copyright lawsuits they see in the US. So
perhaps I think it's a bit of a gamble at the moment.
Yeah.
But as is one similar, I think this conversation is very similar if we go back less than 10 years with the GDPR. And there were websites that were not for a few months accessible to the EU because, GDPR not compliant. But honestly, right now, to me, that's gone away, right? The market has fixed that a little bit. There are still, every now and then, I find a website that says, okay, you're in the EU. If you don't give consent, then you cannot access. To me, it's not even exact as an assessment. So my expectation is that, and the big gamble is that the EU market is too big and remunerative for avoiding it. And that's, I think, is the bet also of the EU legislator. You say, okay, we know that we make it more costly, but is not, the extra cost that we are imposing is still smaller than the cost for you to give up our market.
Right.
That I think is the gamble, and I honestly think it probably will work.
okay, great. Thank you so much.
Thank you.
Thanks. Question in the back. Yeah.
Thank you very much for this enlightening speech. Myself a lawyer, so I can super relate to the difficulty of PowerPoint. There is talks about potentially adopting the copyright directive. So I have two questions. One is, do you believe there is adaptations necessary because the AI doesn't actually change anything in the copyright directive? But it's also already clear that none of the, or most of the AI providers do currently at least not respect a robot text, for example, the manifestation of the opt-out possibility in the copyright directive. So do you see need for adaptation, or what would be what are you advising the Commission about? And the second point is, do you have like a feel for the US and whether this would be considered fair use?
So when the CDSM directive, the directive that passed the 2019 that introduced the text and data mining exceptions, but also the Article 17, so the famous as filtering obligations, and Article 15, famous as the press publisher right, etc., passed, the rumor was, well, this was so lobbied, it was so intense, it was, it soured so many relationships that it won't be touched for the next 10 years or something. And then the Commission changes, and then they tell me, well, that's what everyone says every time, and then the Commission changes. So there may be new energy, new visions, etc., etc. I don't know, and I don't have any, I'm conducting a study and I'm presenting my my results, and then these results may or may not be used. So I don't have any insider view. That's what I want to say. It's true that it's common knowledge that there is an initiative, particularly dear to right holders, to change the copyright directive or the relationship copyright AI Act to make clear that generative AI is not covered by the text and data mining exception. I think that it's unlikely to succeed in these terms because the AI Act was just passed and the AI Act explicitly say that the text and data mining exceptions are the legal basis for generative AI training. So to me, something that has so recently been approved through a complex process of compromise has little chances to be changed so soon. Should it be changed? Well, one thing should be clear. If it changes, it will change in the direction of less exceptions. So you will need to buy a license from copyright holders to train your models, and that will slow down even further innovation under this point of view. One of the elements that the Draghi report identified is the lack of competitiveness in a few areas that are over-regulated. I think that the expression we often use is that the EU regulate and the US innovates. I don't entirely agree with that. I believe that the ambition to embed EU core values, privacy, the protection of property, intellectual property, freedom of expression, etc., in how we design the laws, and therefore the technologies that have to develop within that laws, is a good ambition. Of course, it's always possible to make it better, to write it more efficiently in a way that innovation is not hampered. The TDM exceptions passed as they passed because at the time when they passed, we were talking about text and data mining, not about generative AI. All the other venues where I speak that are considering to pass a new text and data mining exception, I go often to South Korea because they have an important copyright forum, but in many other countries, they are clear. We missed our window. If we were to pass something right now, there would be not enough support because everyone is too afraid of generative AI. It destroys authors, it destroys coders, it destroys all the jobs. So the feeling right now is not towards a broader exemption, but if anything will change, will be towards a narrower one. And I'm not sure that that is a good idea. I want to save authors. I teach copyright, but I think that the right way to save author is a different one. Is not through this. In the U.S., there was that big debate on and the strike of Hollywood screenplay writers, and the solution there was not in copyright, was in that specific case in labor law and in the agreement that the studios will not use AI to substitute authors. And I think it's a sensible solution, has nothing to see with copyright. Is it fair use? I think that right now fair use has been used to justify most of these activities. It will be litigated and we will know better. There are various factors that need to be assessed. I think that the US has a track record of implementing fair use quite consistently in the relationship between technological development and protection of right holders. I'm sure that in many situations, probably it will remain available, but there will be clarifications by the courts on what exactly needs to be done to balance these two rights. But again, I'm not a US-based lawyer, so I'm sure that someone with trained in US law could have more specific feedback for you.
Thank you. And we are running late, so that's no more questions. And thank you very much for the presenters once more. And now we will continue with the coffee break, and then after the coffee break there will be the parallel sessions. So please go for a coffee and then find your room where you can go further on. Thank you very much.
This session where we would like to focus on collaborative learning and data and model sharing. And already now in this symposium, we have several times had the discussion about how to share data, how to interact with each other, because it's obvious for everyone that this journey on application on data into artificial intelligence and all the work that we have seen here is possible we have been presented here in keynote in the morning. That really shows that we have to collaborate and we have to take the journey together and to learn from each other and also to share. And that will be the focus on this session in the next 1.5 hour. We have 3 speakers. One of them has unfortunately come in a situation where he will not be able to be here physically. That's Mano Kovanic from Greece. But he has recorded his presentation, and it will be given here as we have planned for. But of course, it's a pity that he is not here. But this is the best solution. I also have to say that the session will still be recorded, so you should be aware of that. I would like to introduce the first speaker, and that is William O'Sullivan. William is a head of data science at Cream Global. We will probably hear more about that. William is responsible for designing and implementing systems to tackle challenges in the food safety space using data. And in most recently, he has been focusing on the unique benefits of challenges associated with collecting and sharing private sensitive food safety data. And that is already one of the issues that have been mentioned yesterday. So very welcome, Will.
Thank you very much. Hello, everyone. Just going to Lovely. Right. So thank you very much for the introduction. Fundamentally, this symposium is about getting data ready for the use of artificial intelligence. And as Akash mentioned yesterday on his own panel, we are seeing magnitudes of 2 to 3 to 4 times of the data that should be available for making decisions locked behind the private doors of industry. So in order to open up those doors, to get access to that data, to make the best decisions possible with the data we have on hand, we need to facilitate some kind of sharing of that data, some transmission of that data, access so that the right people can make the right decisions on the right information. Very good. So why share data? Very much these same kind of points, these ideas of making sure that we're making the best informed decisions possible. So let's start with a bit of an example here. We have a trend that is impacting food safety, and it is developing. It is a current event. We are collecting information about it. It could range from climate threats, so regional temperatures increasing. It could be a supply chain issue with the price of a commodity rising. Or it could be, at the consumer level of all of a sudden a new trend has landed and consumer intake of an ingredient is increasing. But it is too late. By the time we have a lot of this information, the risk has emerged. People may have been hurt. Worst case scenarios, some people may have died. The way in which we're collecting data at the moment is only really capable of helping us kind of analyze trends that have occurred historically. And so we have to wonder, can we put together safeguards that are going to allow us to avoid issues like this in future? Are we able to use predictive analytics to anticipate events like these based on data we've collected so that, the risks that have developed, that have formed these kind of case studies are not just once-off events that we kind of attribute to the random aims and wonders of how volatile food safety can be. How can we make better informed decisions based off this data? First things first, we do have to acknowledge that there is uncertainty inherent in all of these kind of systems. It is very, 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 very unlikely that any of us are going to be able to account for all of these possible parameters, regardless of the modeling tools or techniques that we have available. Unlikely things do happen, and we are reasonable creatures, reasonable actors. We're not going to assume that the craziest scenario is going to happen every time. And we're also not necessarily always going to have the bandwidth to consider the nature of diverse threats to food safety. Fundamentally, it is important that we're not just analyzing data from this historical context, but that we are also informing, beyond the single case scenario. We are saying, if you're a person with years and years of expertise in the field, How is history not necessarily repeating itself, but how is history rhyming with itself? What trends are you aware of that can help inform, the scenarios we're going to be examining? After this point, once we're trying to map out this state space of potential problems, we have to model like hell. We really have to go at this with all the tenacity that we can in order to describe the broadest range of scenarios that would possibly occur. Ultimately, if we are scientists, and many of us are, it is our job to inform policymakers what the best course of actions to take are in order to keep people safe from harm. We have to come with the appropriate analysis. And at this point, we start looking at a range of scenarios here, and we have to start examining what are the actual worst-case scenarios, how can we prepare that guidance, and make sure that it is presented proportional to the appropriate risk. You can have very high severity events that are incredibly unlikely to occur. Conversely, you can have very unproblematic events that will occur every day. And how you strike a balance between what really poses a risk to human health is functionally your job as someone who works in food safety. But as we kind of prepare what this analysis looks like, as we look at how we model into this space, we have to remember that as a field, predictive analytics aren't going to be perfect. There are problems that they are best suited to solve. And I think it's important we acknowledge limitations where they do exist. I'm very much in that remit of what problems am I able to solve with the data I have today and tomorrow, not the data I would love to have in 2 years' time. We need to accept that those modeling techniques are only going to work on the data we have at any given point in time. We should also aim to model known risks. So previously I mentioned these high severity, high in likelihood risks. Trying to model those will make you pull your hair out. It is unfair to try and think that you will model and classify out scenarios where unlikely events are going to occur, because you, like in most food safety scenarios, are not going to have the data to support an appropriate model. You might get really lucky and find a key driver that hasn't been analyzed before. You are more likely than not to not get lucky. And finally, if we're going to be looking at solving complex issues in the space where, food safety has historically been given a lot of simplification because we can't account for all the variety and variation we'll be seeing, we might as well make a simplification here that gives us very wide error bars so that we can at least be right when someone tries to hold us over a decision. If we're going to try and model complex systems, we need to be ready to prepare complex data. And we might wonder, okay, if we're going to start collecting data of scale that is complex and not trivial to put together, where do we start? How do we start doing it? What can data sharing actually allow us to do? Where does it fall down? If you are getting into the space of trying to model risk, you are going to start with the information you have. This is a good place to start. Please do not try and start modeling with data you do not have. Either at your department level or at your organization level, this is data you should have access to, even if you have to jump through a few kind of administrative hoops to get access to it. This is information that will lay out, in the simplest terms, the trends that your organization or department have already been interested in. Therefore, your follow-on analysis should be able to capture the fact that, okay, we've analyzed this data so far, we've made some initial decisions, where do we go from here? The next step is, naturally enough, extending out both into literature, so that's published research data, and also then reaching out to other governmental bodies. There will be regulatory data that your organization does not have in reserve that might be even trickier to get to. There might even be international data that you can also get your hands on by forming partnerships with relevant actors who want to solve common problems. This data might be free. It might not have a cost associated with getting your hands on it, but there's going to be a lot of processing work to pull that data into a form that is compatible with what you already have. Because again, when I'm thinking about how we solve these problems, if we start with the data we have, we start baking in some assumptions pretty early. It is rare to see someone designing a model that is, perfectly accepting of all data in all forms. You're going to start with a few preconceptions. When you start pulling in different data, some of those preconceptions are going to be changed and challenged. And finally, I'm talking about bringing in a third tier of data, which is this commercial information, this shared data. One of the reasons that this kind of data can be so valuable is not just the volume, but also the specificity with which it's collected. Certain commercial interests align very carefully with, I care about this one quality parameter because I hired 6 or 7 people out of food safety from a given point in time. We've been collecting data to this effect accordingly. And the challenge here becomes, yeah, this isn't going to be free information either. So why would a commercial entity want to share this data in the first place? And so we prepare these benefits of data sharing accordingly. Naturally enough, if you are a food manufacturer, if you are working in the agri-food space either, you're going to want to make your product safer. And we can say that it is because, you know, these companies are deeply interested in the well-being of people. It is also, and I'm saying the quiet part loud now, it is also a bottom line issue. Recalls are expensive. Having to hunt down food safety issues after they've occurred can do lasting brand damage. It is good for food safety and is good for business to, you know, engage with safe food. Naturally enough as well, sharing data reduces your costs of data acquisition enormously. For pennies on the dollar, by sharing, bartering functionally with your information, you can get access to data that your organization wouldn't have had. If an organization, a commercial entity, is data-driven by nature, it is going to want as much information as possible to make the best decisions as possible. So by the very virtue of sharing data, you are just increasing the volume of information you can make decisions on. And finally, these companies will likely be doing modeling as well, be that for the price of their commodities, be that to anticipate supply chain disruption. They are going to be very concerned with making sure their models, with their forecasts are going to be as correct as possible. And again, the best models come from the best data. So ultimately, data sharing isn't limited just to industry or to governments. You know, it is possible to bridge that divide pretty handily. There are instances of industry sharing data with governments and vice versa. And so this is something I'll be going to a few case studies on in a moment. But the mechanism for sharing this data, how can data be shared in a way that starts addressing, naturally enough, the concerns that surround sharing data? How do we treat the unease that can accompany this concept? This data trust concept wraps up a lot of worry and distrust in the safety of a legal agreement. It doesn't always have to be a legal agreement with multiple lawyers involved and law firms as intermediaries. We do have instances where we have actually gone that route, and that has been to the benefit of the project. But simply speaking, once people are very clear about what the data management plan in a joint fashion should be between organizations, all of a sudden barriers start coming down where the lines of responsibility get clearly drawn out. Nobody is going to want to commit to kind of sharing information on an ongoing basis if it is going to come with unforeseen burdens. So being very clear and upfront about how to do that, is the right way to do it. Additionally, a platform to share data enables a much more kind of comfortable transfer of information rather than saying, hi, I will email you this much confidential information. Please don't forward this to someone else in your company. Being able to create the apparatus by which data is shared is another kind of crucial step to making sure that people feel comfortable that when they submit data for sharing, it ends up in the right place. In terms of data privacy, there is very much this kind of common idea that when someone submits data, they are not losing control of it. You control your own data access in line with the agreements that you've defined with your partners in a given data trust. And so I've got the diagram here of kind of what a typical data trust would look like. So we have an organization 1 represented by users 1 through N that are capable of submitting their own set of data and aggregating it in the first place. So one of the kind of intangible and then later tangible benefits of working with a data trust is this idea of, oh, I'm suddenly now becoming more data savvy. I'm getting my house in order. I think it's a kind of common falling point for the food industry that the collection of data is not necessarily one of our historic strong suits. Exercises like preparing to share data make your practices better. That data is then aggregated and then kind of supplemented with public data, and simultaneously you have other actors involved as well, different organizations that will also be submitting their own data into this view of engaging in predictive modeling, predictive analytics accordingly. And then, of course, for the purpose of communicating out, artificial intelligence gains, you're going to want to present that graphically. That is a much nicer way to kind of capture people's engagement. It also lets them interrogate scenarios a lot better and a lot more in a kind of as one would expect to engage with any kind of system that is going to be helping them make decisions, they're going to want to ask a few questions, dig a few layers deep, filter down on data, understand what kind of decisions are being made. And at this point, we can start talking about a few of the different case studies whereby data trusts like these have been implemented. And I've got 3 examples. One that is kind of sitting in this very industrial space, looking at food fraud. I have a case that is looking at a very governmental regime where we're starting to talk about U.S. government agencies sharing data, and we also have a regime where we're actually bringing this kind of data technology not just to food manufacturers but to the kind of primary agricultural producers of leafy greens. So FIN is this organization that has been set up to kind of give insight into risks to food fraud via an anonymized data sharing platform. There are a load of different industrial participants here, based primarily out of the UK, and it is critical to acknowledge the fact that sharing any kind of data between what are functionally competitors comes with barriers. But putting aside kind of those initial commercial concerns to better understand all their shared supply chains is very much kind of in the interest of an entity from the size of Sainsbury's to Tesco's to Morrison's. All of these entities that would otherwise have the ability to kind of do some rudimentary data analysis are starting to get access to the likes of Asda's supply chains and Premier Foods as well. Very simply speaking, when we started with FIN, a lot of these organizations did not have perfect data management plans, and that's okay. Everybody starts somewhere, and it's really important to meet people's data where it exists at a given point in time. Accordingly, to get all of this information into the format that we needed to actually allow for a meaningful aggregation and analysis required that you create a lot of different routes for people to succeed. So that can be a very simple kind of upload functionality where you submit a file that you have either as a nice tabular Excel or CSV, or potentially even like in a PDF form. Then we have to go through the work of extracting that, but that's okay. If that's where their data is, we're going to try and make this as easy on people to share data as possible. There has to be some way to take down these technical barriers that are just otherwise a lot of work. Providing the tooling to do that is important. But then, of course, you do have some participants who are going to be technically savvy, who will have good data infrastructure and can simply fire data along their APIs to make sure that, okay, cool, we are kind of meeting our obligations under the sharing agreement that we all defined, so that ultimately this kind of collective analysis can take place. The FIN data trust structure does include that degree of legal privilege, though, and it's actually a double-blinded data trust. So what that means is when we're provisioning this kind of, this platform, that there's a separate legal entity involved that we actually send account credentials to, that they then assign in such a fashion that we never know who's submitting FIN data. All we know is that when we get data back, that the list of companies described previously have their information represented out accordingly. Then, of course, we get to this kind of, this visualization of these trends, looking at the risks of food fraud or risks of adulteration. And we can start kind of pinpointing countries where we're starting to see emergent issues in the likes of olive oil or honey, essentially commodities that are at risk of being either faked or adulterated. And we can start breaking down these trends by the food groups and classifications as well, so we can start looking at emerging trends in our specific group of meats all of a sudden becoming risky. Are they not? And how can we kind of verify that what we're seeing on the package is what it says in the package? Further than that, though, we go from that level of deep exploration of data to the simple refinement that is, okay, you need to go to your stakeholders now and communicate a very simple message that either fruits and vegetables are becoming safer according to the fraud data that you're submitting. You are less likely to see something that is adulterated or reported in a way that it should not be, but you are seeing that meat is becoming more of a problem. Go ahead and start running more tests. You can take the focus off of one group of commodities, put it onto another, better allocate your resources because you're sharing data that is collecting a trend across your industry. Very simply, these benefits manifest as the ability to kind of anticipate changes in your food supply chain. as a way to figure out, am I right to anticipate a given threat to my food supply chain as well? And additionally then, to functionally be crowdsourcing knowledge across 63, 64 different companies. So that very much is a benefit beyond, just trying to analyze the data that you had collected solo. Every single one of these participants gets access to unique data they may not otherwise have had. With the FDA, as part of that era of smarter food safety, they wanted to take advantage of the ability to try and share data, both across agencies and with industry accordingly. To this effect, they wanted to start putting in place, a trusted method for data sharing. All of a sudden, the data trust name makes all that much more sense. Everybody wants to be able to work off of the same common corpus of information. How do we collect that? We get different parties who also want to continue that study from their own different kind of perspective to share data accordingly. Fundamentally, there are a lot of benefits that do wrap up why an organization like the FDA would want to share data. One of the big things that we have found is in that breaking down of different silos and highlighting what some organizations are doing well versus others. What agencies are collecting data that is really relevant to human health risk and, in fact, creating predictive models. You might have a set of in-house lab testing data that is able to tell you that a given commodity is at risk at a given point in time, but you might need another agency's data to start actually saying that, oh, and this is why it evolves over time in this certain way. A good example here would be a blending of the FDA's own data with the EPA's data in terms of PFAS in the water supply. Fundamentally, it's not just about looking at single kind of issues though, but using this ability to extend your data infrastructure to look at multiple different types of hazards as well. So of course, PFAS, because this is a big ticket item. Also, you're going to want to look at other known hazards like toxic elements, the emergence of biotoxins, how materials are decomposing, and whether or not those are actually kind of aligning with what you are expecting when you are importing the vast majority of certain commodities to your country. So for example, the US imports over 90% of its shrimp. If it's not trying to take care of the fact that some of that food might not be in perfect condition by the time it arrives in a port, there will be adverse health effects. Ultimately, if you do want to kind of find out more about how the FDA is sharing data, I would encourage you to reach out to the FDA themselves about it. Of course, though, there we are. This helps the FDA kind of design and define its own data strategy. You're able to ask better questions, inform sampling plans, make decisions about if our data isn't perfect for modeling with now, what do we have to change so that it will be in 2 years' time? It is possible to make good decisions not just about food safety, but about the data that governs how you think about food safety based on sharing information like this. Additionally, if you're mixing different data types together, different sources of analyses, you're going to find patterns that previously would have been siloed before. And finally, again, same as with Finn, you're going to better allocate your resources for testing. If all of a sudden all of your models and all of the data is saying, actually, this commodity is completely fine, with a few key indicators we can keep tabs on, but otherwise we're happy to allocate resources elsewhere, that is an important consideration for an entity like the FDA to consider. And finally, we're looking at the study of agri-foods. Here, leafy greens account for about 50% of the kind of food safety issues in the US. And so leafy green producers have kind of banded together in order to try and bring that down. Because leafy greens can't have a kill step like a lot of other foods can, it's very important to make sure that what we're collecting in the field, what we're testing, is representative of the health outcomes that occur down the line. So this is the kind of platform that growers, literally the farmers themselves who are growing this produce, are able to finally participate and start bringing their own data to bear as well. Because again, they must consider, is it onerous for us to be examined? How do we have to destroy crop if it is found to be contaminated? What do we change in order to be as compliant as possible? And it's very fair to say that arming the regulators with information in advance makes their lives easier and makes your life easier as a grower, by virtue of the fact that you can actually share information, be a part of kind of what trends the FDA sees are emerging, and respond accordingly. Naturally enough, this does bring along the advances in the food safety, so they can start also changing their SOPs and their testing practices in line with what should be detected in the field. They're able to optimize for cost. They're able to optimize for cost on account of the fact that if you have a field that is known to never have any issues because it is perfectly positioned in such a way that any nearby dangerous runoff never going to hit these crops, cool. You can lessen a testing regimen here. You can increase one further downstream. You can essentially adapt your testing protocols to the landscape based on the data you're collecting. Additionally, pulling out information on trends, of course, but then moreover, sharing data with the regulator is a really nice way to build trust with the consumer. All of this food has to be FDA approved in the first place. It is really nice to know that your providers are also going to the extra lengths required to show and demonstrate consistently that the food is safe, that it is currently safe, and that it will continue to be safe based on the most up-to-date testing protocols. All right, and that is that. Thank you very much, people.
Thank you very much, Will. We have decided to take maybe a single question, but not the full discussion now, because we hope that we will get time by the end to have a more broader discussion. But if you have any, yes, there's a question down there.
Thank you for the good presentation. I'm working for EFSA, and we are working since years on this data share principle. I would like to connect this presentation to the main discussion we have on AI. And in many cases already some years ago, we were challenged about creating this data collections structure with the fact that the arrival of the AI will change everything, and there will be no need to create this data share because you will just get the information in a much easier way without any kind of data collection. So how do you reply to this kind of questions?
And I'm not trying to be too cheeky here. My question is, how does that really solve the problem, right? If you're going to be trying to change your models, adapt your models to give the best predictions possible, and you're saying they don't need data, I'm not following that real line of thinking. I understand this idea of automated crawlers who are able to pick up data, analyze that, and help you model. We don't need private data if we've got plenty of public data that we can access. I would challenge the notion that we do have plenty of public data to access. If most of our information is going to be locked behind closed doors, companies that are collecting data but refusing to share because they kind of either fear punitive measures or they fear kind of losing a given competitive edge, it's important to try and acknowledge that we are trying to model best for an industry as a whole. It is also important to accept that AI isn't going to necessarily be able to perfectly reproduce the story that these primary producers are going to be collecting. So I would challenge that notion that AI is going to address this issue of data sharing. I think it's also fair to acknowledge that data sharing comes with its own problems, it comes with its own trouble. You can create systems whereby people understand and agree to what data should be shared. You can create platforms that they can submit data to in a very easy way, and you can make it so that this data, extracting this data, is as non-onerous as physically possible. You still have to kind of win the battle of the minds and convince people that working together for the safety of the industry is a good thing. So apologies for maybe not answering your question in the most collegiate way, but yeah, I would think that data sharing and the collection of data is still really important. I don't think AI is going to get us there by ourselves, not at least yet. And I'm so concerned with modeling on the data we do have, and I know industry has data that is really important for us to get access to. Thank you very much.
Yes, a single question.
Sorry. I have a question regarding the anonymity of the users providing data. My scenario that I know is in a microbiological outbreaks, pathogens and so on, usual story related to food, etc. And you are right. Most of the data are in industry. They are fair to share and to find out they have the problem.
Yeah.
But they would like, at the contrary, they would like to know if they have problem. Yeah. Sometimes industries do not know if they have problem, they would like to know if they have problems. So would like to share, but in a blind way. It would be also okay because they can understand, comparing what is public available, if they are in a critical situation or not. Do you address these things on your platforms?
So yes is the short answer, and kind of a fun extension of that is, you know, when you're trying to figure out why an issue is happening, having a shared source of data can be a very quick way of saying, oh, this isn't an us problem, this is an environmental problem that'll be, you know, affecting every single person in the supply chain. Or it will say at a very kind of granular level, okay, we've actually identified that this one field is a problem, let's focus our kind of resources there. Let's make the best decisions we have based on the fact that we have a whole load of data to consider. So it isn't always just about providing the predictive modeling aspect. There are a lot of times where folks who have that kind of on-the-ground level expertise are also able to interpret the data as it's presented to them. We can provide projections, so that is kind of the AI component that we kind of bring to the table. But oftentimes, you know, in terms of responding to an issue that is emerging, you're going to have experts there available who will kind of help diagnose those issues as well.
Thank you very much to you, Will.
Thank you.
And now we will continue with the recorded presentation from Manos. Manos is an experienced computer scientist with over 15 years of experience in research and developing. Now he's head of innovation in AgroNeo, and he leads an interdisciplinary team in creating advanced AI solutions for the food sector. And he also looked into the potential for the food industry to collaborate train food risk prediction model with respect for the privacy of these data. So could you please put on the video?
Hi everyone, I am Manos. I am the head of innovation at AgroNeo, and today I will be talking about how we can pull together data from multiple private sources to train predictive models for food safety risks in a privacy-preserving way. As you'll see, my presentation is light on technical details, but we will be exploring a lot of the core ideas and challenges in making collaborative AI model training work in the real world. So for this, I will be using a specific industrial use case that is coming from the EU project we are coordinating, which is called EFSA, which stands for Extreme Food Risk Analytics. So let's start with to establish the specific use case. So let's say we are working directly with a poultry company that is managing a set of poultry farms. And what we want to create is a salmonella contamination AI model. So we want to better understand the conditions under which salmonella might appear and proliferate inside a poultry farm. So the issue with this is that, fortunately for the poultry business, contamination with salmonella is an extremely rare case in any single business. So the positive examples we're going to have from this dataset are going to be extremely limited. So our first instinct might be, okay, let's pull together some more poultry companies that are managing their own poultry farms in this picture so we can create a larger dataset where more positive examples are present. Of course, that's okay in a sense, it's a good idea. And in a typical manner, in a traditional approach, what we would do is to ask each of these poultry companies to submit their own data to us, to a centralized point, where we will go ahead and explore the data, clean the data, and finally train the predictive model and validate it. Of course, what you will hear from each one of these industrial companies is that, yes, of course, I would like access to the final model, but I'm very hesitant to give you access to my own data. What if they are exposed? I might have legal liabilities around them, or some of my trade secrets might be exposed, or my reputation may be hurt. So what we'll talk about today is how we can get the model trained without exposing the industrial data sets of the participating companies. So this looks more or less like this. Instead of sending the model and sending the data to a centralized point, what you do is you let the model get trained directly over the premises of the participating company. So in a sense, the model travels around in the companies, gets trained locally with all the data, and then you have a model that is trained with all the company data without the companies having to submit their data to a third party. Now, that's more or less what we're exploring in EFRA, such type of sector-specific intelligence sharing networks that can be built around privacy-preserving AI. So that was a nice picture, but of course it's never that easy. So next we'll see some of the key challenges in making this work. So let's start first with having a better look at how exactly what we're trying to do here, which is called federated learning, is traditionally done. So the picture is a bit different from the oversimplification we saw before. So we start by each company using their own data to train a local model. In our case, a local salmonella contamination model. So 3 models trained at each one of these facilities without using the data of the other companies, only your own local data. What you do then is you send to a centralized point, not the actual raw data. What you send are the model parameters of the local model you have trained. These model parameters are then used to put together a global salmonella contamination model that, in a sense, incorporates knowledge from each one of the local models. This global model gets trained, and then it sends its own model parameters back to the companies. And then you do an iteration over it where you retrain the local models based on the updated parameters you got from the global model. And of course, you can do this iteratively until the global model converges, until its own parameters don't change that much. So at that point, you have the global model trained. Now, the very interesting thing here is that this nice picture actually has 2 fundamental assumptions built around it. The first one, which is rather well known in the community and well studied in research, is that this picture assumes that all data sets are more or less similar. We'll see what this means in the next slide. The much more interesting assumption for me, and a key reason why our research project got funded, was to explore the second assumption, which is that each company can train a meaningful model locally. Okay, so we'll have a look at each one of these 2 assumptions in the next slides. Let's start with the first one, that all data sets are similar. And let's have a better look. Let's see if there are any biases here that we haven't thought of in the beginning. So let's say that the poultry company at the top resides in a cold and mountainous region. The other company at the bottom left in a warmer coastal region, at the bottom right in a dry and inland region. So the first company at the top could have the following correlations inside its data. It could say that salmonella risk is mostly correlated with increased confinement during cold periods. In the other company, it could be that salmonella risk correlates more strongly with high humidity and warmth. And in the third case, that salmonella risk correlates more strongly with dust concentration and water quality. So the data sets appear similar, but they have different statistical properties. They are biased in a different way. Now, the way, as I said, this is a well-studied problem in research, and we have a lot of ways to deal with it. One of the key ways for how you can deal with this is that at the end, when you have your global model steady, when its own model parameters have converged, you add one single extra step where you send this global model back to the companies. And what they do is they use their own local data to fine-tune the final global model in what we call a transfer learning approach. So this is an approach where you emphasize the local patterns, so your own statistical properties of your own data, of your own case, and at the same time you might maintain the global patterns that the global model has identified. So that's a way to deal with biased data. Now that's an interesting assumption. Let's look now at assumption 2, which for me is much more interesting. And this reads that each company can train a meaningful model locally. To understand this better, let's introduce a tougher problem, okay, that is related to what we have been talking about, but it's a bit tougher. So let's say we have one data set, so one participating company that has poultry production data. This is a private sensitive data set that has been provided by a large poultry company under the condition that nobody should have access to their own data, not even the data scientists that are trying to put together the model. And we have another data set on feed mycotoxin testing. This is again a private sensitive data set provided by a countrywide testing scheme under the same requirements, under the same provisions. And what we want to do is to use these two data sets to train a combined AI model that predicts the effects of mycotoxin levels in animal feed on key poultry production parameters. So that could be gas emissions, weight gain over feed consumption rates, or pathogen proliferation. Okay, so let's see how this looks like. So in this case, we have two companies. Our feed testing scheme at the top, which provides the mycotoxin testing data, and our poultry company, which provides the production data. And let's look at this assumption here, that each company can locally train a meaningful model. So if we try to train a local model at the top, the only type of model we can train is a mycotoxin model. We don't have access to other data apart from mycotoxin testing. And on the other hand, the poultry company can only train a poultry model, a model for poultry production. But what we want to do is actually to create a model that combines these two. So this concept cannot work because we need access to both data sets at the same time on the same point. But we can't do it because this will breach the privacy and confidentiality requirements under which these data have been made available. So let's try something different, because this is indeed a tough problem. So an approach that we are exploring is this. Instead of creating a local AI model, what you create is a local synthetic data generator. What does that mean? You use the data that you have locally to train a model that is able to produce fake but realistic data that follow the similar statistical properties as your own true data. So the synthetic data generator of the feed testing scheme can create fake but realistic mycotoxin testing data, and the synthetic data generator of the poultry company can generate fake but realistic poultry production data. You give these two synthetic data generators to a central point, to us, to data scientists, that put together the combined AI model. And that's an interesting approach because nobody has access to the actual data. So you maintain something very important. You maintain what we call plausible deniability. So even if the data were exposed, the data coming from the synthetic data generators were exposed, you could say that, no, these are not my data, these are fake data. So you don't expose your actual data, but you can meaningfully train an AI model using these synthetic data generators. Now, of course, there is an issue here, and some of you might have already foreseen that. The data scientists, this point where these synthetic data generators are made available, if they were bad actors, could they attack the model? Yes, they could. They could not gain access to the real raw data, but they can infer sensitive statistics. For example, using the synthetic data generator of the poultry company, they can infer their mortality rates. And that might be an issue. So one way to deal with this, because it is a weak point of this approach, is that you can do what we call differential privacy. This is the idea that before you create the synthetic data generators, you add some noise in your data. So in a random way, you flip some lab tests from negative to positive or from positive to negative, or you change some of your values by adding a random number. So the more noise you add, the more you can enhance this idea of plausible deniability, and the better you preserve confidentiality, but the more you create statistical properties from the synthetic data generators that do not closely follow the data patterns, the actual data patterns. So there's a trade-off here, but there is a way to use differential privacy along with this idea of synthetic data generators to tackle tough cases where the federated learning approach would not work in its traditional manner. So that was all. Again, I would be very happy to connect with you through LinkedIn. And if you have the time, it would be great to check our own European project as well, which is called EFRA. I have links for both my own profile in LinkedIn here and for the project overall. Thank you.
Yes, and unfortunately, there is no possibility to ask questions to Manos here, but he welcomes you to connect to him. So I will give the floor to you, Leah. Leah is working as a research associate in the KIDA project, AI and Data Accelerator, at the Office of Digitalization think tank in the German Federal Ministry of Food and Agriculture. And actually, we are now moving further out for the researchers, for those who actually work with these activities and have to implement new methods. So Leah is involved in a group a service unit that supports scientists to implement of their research project by realizing the potential of data and artificial intelligence in the field of food and agriculture. Please, the floor is yours.
Yes, thank you very much for the introduction. Well, we have now learned about different solutions of how to share models and data for collaborative learning and while preserving data privacy. And I now want to show you how we are sharing data and models in our project called KIDA and how this benefits researchers by providing comprehensive solutions to support their AI projects. So KIDA stands for AI and Data Accelerator, although this acronym actually only makes sense in German, as I realized. And it is a collaboration of different German research institutions that are working in the field of food and agriculture. So we all know by now that artificial intelligence is a fantastic tool to analyze huge amounts of data much better, or at least much quicker than humans can do. However, we realize that employees at these research institutions oftentimes face multiple hurdles when they want to use AI in their projects. So I press here. Yes. So in a state analysis conducted in 2022 in the participating institutions, we were able to identify the following main problems. So there's a lack of technical infrastructure that is necessary for complex AI calculations. There's insufficient know-how in the field of AI and the need for expert support. And there's a challenging usability of already existing AI models for other use cases. And there's a lack of networking as well as training opportunities on the field of AI in these institutions. And this is where KIDA comes into play. KIDA wants to solve these problems and has three main goals. So the first goal is to strengthen the AI and data skills in the institutions. But this should be done in a sustainable manner, meaning that we want to develop skills and knowledge and also make sure that this knowledge is shared within and between institutions. The second goal is to expand the technology infrastructure. And again, this should be done in a more sustainable way. So we want to establish and operate a shared technology infrastructure. So we are actually sharing resources here. And last but not least, KIDA wants to improve the use of data for AI applications and the use of AI models. So that means we want to offer AI solutions as interoperable services. And when we're talking about sharing data and models, one aspect that is very important is that we have to clarify the legal issues. So this is another focus of KIDA. So how are we doing all this? As I said before, KIDA is a collaboration of different research institutions. You can see these institutions here. These are 7 German research institutions. They are all part of the German Federal Ministry of Food and Agriculture. And in KIDA, they are working very closely together, so we can actually take advantage of synergies, such as a much faster and more cost-effective development of solutions. And thanks to this collaboration, we are able to provide this service circle that you can see here. So when a user wants to use AI or data technologies in their project, they usually submit a service request, and we can offer some understanding and some consulting. And then we also offer the necessary technology infrastructure for that project. Then we transfer data and we develop AI models specific for that project. But then we do not stop here. We also want to make sure that the models developed can be passed on easily so they can be reused by other researchers and by other institutions. And then we also want to share the findings of each project within and between institutions so everyone can benefit from one project. So to be able to provide this service circle, we established 6 different service areas or service units that are listed here. And these service units are all part of one or more steps of this service circle. And the service units are usually made up of members from the different institutions. So I would now like to present each of the service units in a little more detail and give you some insight into how they support and benefit from the idea of collaborative learning here. So let's start with the AI consulting unit. This service unit consults employees or researchers on the topics of how to use different AI technologies, but they also develop customized AI solutions for their projects. So this is actually the main part of their work. And I would like to give you some insight into what kind of projects they're working on. So here on the left-hand side picture, you can see a picture of a mixed forest, which was taken by a drone. So on this picture, you can very easily see the different trees. And on the right-hand side, you see a picture of that same mixed forest, but this picture was taken by a satellite called Sentinel-2. And you can see clearly there that this is a very coarse resolution picture. So actually, we can only see pixels and different shades of green. But the goal here was to be able to classify different trees on these satellite images. And it was actually possible by training a neural network on the satellite images. And it was also very successful, reaching a 97.9% accuracy in the classification of background, of conifers and deciduous trees. It was also possible to recognize changes on the satellite data. And as you can imagine, this kind of AI solution is very useful for different reasons, such as environmental monitoring and determination of biodiversity. I would also like to show you another example of what this AI consulting unit is working on and show you some project that is a little bit more related to food safety. So here on the left-hand side picture, you can see sunflower oil, which is actually very cheap compared to cactus oil, which you can see in the middle picture. And this is very expensive. And the picture on the right-hand side to us looks exactly the same, but it's actually adulterated cactus oil. So that means it's mixed with cheap sunflower oil, but sold at the same price as pure cactus oil. And the goal here was to be able to differentiate between pure and adulterated cactus oil and on the basis of different analysis parameters, and then to be able to detect low concentrations of adulterants. So I actually do not want to spoil this here, because if you are interested, my colleague, Micha Schneider, is actually giving a presentation on this exact project later on after lunch. So for anyone interested in how exactly this is working, I highly recommend going there. I think it is on session 3. Okay, so for the AI consulting unit to be able to develop and to use AI solutions, we need the technical infrastructure. And this is what the infrastructure unit is providing. So as I said before, in KIDA, we are establishing a shared technology infrastructure. So as you can see on that picture, only 2 of the institutions involved are actually providing the infrastructure. So only 2 institutions need to actually physically install the HPC units. HPC is short for high performance computing, and that's what you need for complex AI calculations. So only 2 institutions need the space for this, and they need the cooling and everything necessary for the installation of HPC units. But in KIDA, all institutions are consumers, meaning they can actually use that infrastructure. So that means here we are transferring data from one institution to another, from consumer to provider, and this means that security and privacy are of special interest for us. So we have an encrypted connection between provider and consumer, and we also have anonymized user accounts, just to name some of the security features. So one goal in KIDA is that using this infrastructure should feel like being on the institution's local network for everyone. So they do not really, it does not really feel like leaving the institution's network. Okay, so now we have the basis for developing cool AI solutions, but some AI solutions are actually useful for many researchers. So this is why we have the deployment unit. And this unit develops product-oriented solutions, and if necessary, they also support their permanent operation. So let's give you some example again of what this can look like. One solution actually developed by this service unit is the transcription tool Scribe. And this tool is now actually available in some of the institution's network. So it's hosted locally on the institution's network and is accessible by the employees there. And it's very easy to use. They don't have to install anything. They can just go on a website and use that tool. So you can see a screenshot here of what that web interface looks like. And there you can choose what you want to do. And if you choose auto transcribe, you do not even have to specify the number of speakers in your dialogue or the language your dialogue is in. You simply can then upload your audio or video file or record it just then, and you receive the full transcription. So I think you can imagine this is a tool that's very useful for many researchers and many different projects. And yeah, that was developed by the deployment unit. Okay, so, but not all AI solutions are actually worthy of permanent operation. However, we want to make sure that we can share AI models so other researchers can use them for their own needs if they want to. And this is where the data and model usage unit comes into play. This service unit supports the creation of interoperable data and AI models. So to give you some insight again, one service they are offering in KIDA is to transfer AI models to the FSKX format. The FSKX format is the Fair Scientific Knowledge Exchange format, and some of you might have heard of this format before. Actually, my colleague was having a poster session on this format yesterday. And this format was actually developed in the RACIP initiative, which is funded by EFSA, among others. And many of the members of that RACIP initiative are now also members of the data and usage unit in KIDA. So as you can see, the research from the RACIP initiative is now further developed for the case of AI models in KIDA, which I think is a very cool connection. Yeah, so it was originally developed in the RACIP initiative, so that means it was developed for risk assessment models, but this format can actually be adapted to different kinds of models, such as AI models. And this is what this service unit has been done in KIDA. So they made it possible that now AI models can be transferred to the FSKX format, and so they can be easily shared. So this FSKX format is just a harmonized format for knowledge exchange and encodes all the relevant data and information you need about your model in a machine-readable format. Let's have a closer look at this. So in the end, you just have a zip folder with all the information about your model in one place. So you have the model information, such as metadata and the model script. The FSKX format supports different scripting languages, such as R or Python. And then you have also the linked libraries you need for your model script to run. And in the case of AI models, you also have the training data, so the data your model was trained with. Then you can have simulation settings and other information, such as more metadata or publications that were made about this model. Okay, so you have all the information here of your model in one place, and so you can easily share models. However, it is not as easy to transfer a model into this FSKX format. So this is a service they are offering in KIDA to support researchers here. Another cool project this unit is working on is a cloud-based FSKX execution format, so that you can not only share your FSKX models and find different models, but you can also execute them in a cloud-based environment, which makes sharing and using different models much easier. But this is still under construction, so this will be a future service in KIDA. Okay, so when we are sharing data and models, what we always have to consider is the legal issues, especially as we are not only sharing between researchers, but between different institutions. And this is why in KIDA we have a special service unit, the Legal Advice Unit. And this unit is actually the basis, or it sets the framework conditions for our collaboration. So it gives legal advice for employees and for all service teams regarding questions of AI and data, and it also supports all steps of the service cycle. And one important thing they are working on at the moment is the cooperation agreement. So in this cooperation agreement, there are all the rights and obligations of the parties involved in KIDA, and there are also references to how different things are managed in KIDA, which are written in separate documents, and it's actually the basis for our cooperation to work. So this is a very important service unit we have here. Okay, so with all these service units, we are actually creating a huge amount of knowledge, and in order to not lose this knowledge, but to be able to share it and to maintain it and deepen this knowledge, we have another service team, and this is the Knowledge Transfer Unit. So this unit organizes basic AI trainings and specialized lectures on specific AI topics. They also have a community knowledge exchange where they share the videos of their lectures and more information. And they are also organizing a conference on AI for research in food, agriculture, and environment. And this conference is called the KIDACon. So this year is actually the second time they are organizing such a conference. And this conference is all about networking. So the goal here is to bring together stakeholders from the scientific and the regulatory environment to discuss the challenges and the opportunities of using AI in the agri-food research. And it's also in particular an opportunity for young researchers to present their work here. So this year, KIDACon is on December 2nd and 3rd in Leipzig. And if you are interested, registration is still open, so I highly recommend checking this out. Okay, we actually have another service unit, which I excluded from this presentation. It's the management unit, and this is also the unit I am part of. So this unit actually just makes sure that all other service units can work as intended and they can provide their services. But I did not list it here because there's no specific project to show you, so I think it's not of much interest for you, but I just want to mention it. Okay, that's it. This is how we are sharing data and models in KIDA. And I hope I was able to give you some idea of how collaborative learning can strengthen AI skills and can actually support researchers in their AI projects and in their research. And as you see, sharing data and models is not always easy, but it is very important and essential to advance our research. So thank you very much for your attention. And if you have any questions, feel free to ask. I'm happy to answer what I can, or otherwise just get you in touch with some of my colleagues. Thank you.
Thank you, Lea, for this impressive presentation on the system that you have built up. Now the floor is open for questions, for comments, for dialogue and discussion. And even though we do not have manners here, I hope that the two presenters will be able to interact with you. So please raise your hands.
Okay, thank you for the really nice presentation, and especially highlighting the education thing, because I think the biggest problem of what is happening like in the community of food science, food safety, everything is the education part. It's not data sharing, model sharing, how to collect data, but what people are expecting from artificial intelligence to happen, because sometimes AI researchers are doing their own, like think about knowledge graphs, everything, and then some food scientists will say, but we are not expecting as user what this means to me. It doesn't need to be nothing, because Nobel Prize in Chemistry went to AI. It's not went into chemistry, right? But actually the impact what these models are doing without understanding, and it's about trust in data sciences and everything. This is only my comment, and I have one question. I'm pretty familiar with what are you doing like in the group in BFR. How this sharing model is aligned with, for example, Hugging Face sharing models. So for example, before 3 weeks, there was like data sharing, NASA, Google, Hugging Face, Facebook, everyone, they said like all data should be, no matter if it's food, biomedical data, everything should be shared in this cross-SAN standard. Like, do you think like it's something, for example, even if it's private version of your model, right, you are sharing, if there is something interoperability with this Hugging Face standard to share models, because Hugging Face sharing model is a standard in AI with everyone is expecting, all people wants to do this.
Yes, thank you for your question and your comment. I do know about the Hugging Face sharing of models, but to be honest, I'm not an expert of that data and model usage team, so I'm not sure if I can help you here. I could get you in touch with some colleague of mine who's here today as well, so maybe you can talk to him later in some break, because he is part of the data and model usage unit, so maybe he can give you some better answer there.
Thank you, because my comment, my question was related, like, no matter, probably you can have like better standard for sharing models, right? But the power, the brands like which are behind these standards are really powerful. So even you are coming from BFR, from Germany, they are like much more powerful players, and people will go. And this is a really nice project, really, really nice project what you present. And then you said like this was supported by EFSA, then we got another funding, and then in future other fundings to develop this platform. I know that you are doing for your all, how to say, enthusiasts and everything, like people wants to do this, but at the end of the day, like these power names can come and do something.
Yes, that's very true, yes.
Thank you.
Thank you.
Thank you. I think my question is for William. It was very encouraging to see that there were so many case studies for sharing data with this trust concept. I've only heard about the UK Food Safety Agency food trust ideas, and I think perhaps what you described build to some extent on what has been described there. But I think I have 3 questions. The first one is, the participating companies, do all within one trade participate, and could there be any problems if you only get the good ones? So there may be a bias in that. The second one is, if you, based on your experience with these case studies, are there any guidelines or experiences you can share on how to on the legal aspects, on the contracts and agreements? And then the third one is the dashboards. Are they publicly available, or only to the agencies and the companies that do these or that participates? And is there a risk, I guess a little bit along the lines that Manos described, for reverse engineering, that you could get secrets backwards? In my case, from a small country, if you have not that many companies and you have a large one, and you can perhaps see these are my data and I could kind of infer what data other companies has? Could that be a problem, or is that just a hypothetical case? Thank you.
That is a wonderful medley of questions. Thank you so much. Okay, so with respect to the participation of companies, so if we take the likes of Finn, for example, you will have very large retailers there and some smaller retailers as well. You are going to be introducing implicit bias based on the size of different company supply chains. The likes of Tesco will test for food fraud issues in multiple different kinds of commodities. Smaller shops will only test for the things that they sell. So there are going to be kind of fundamental biases imposed by the kinds of organizations that are sharing data. They are still compelled to share the data that they do get. So in terms of the impact, it is relative to the data that is being collected by a given organization. But under this kind of framework of sharing data in this way, it's not like Tesco is only getting data from a small organization and that it's unfair in that regard. It is also the case that Tesco is getting data from the likes of Waitrose, Premier Foods, like the bulk of information they're getting access to is still in Tesco's favor, for example, there. Regarding to the question about guidelines that I would share surrounding the creation of data trusts, one thing I could stand over is this idea of putting together a data management plan to cleanly and clearly define what the expectations are of all the different parties. Finn is the only instance there that uses a legal entity, a separate legal entity, as an intermediary for that double-blind anonymization. Western growers and the FDA do permit us to actually look at the data and trace it back to source to help with the analysis. So there is that component. And additional guidelines in that respect wouldn't be my strength, given my background of the data science side of it rather than the operational component. So I'll limit my comments there, I think. And then for dashboards being publicly available, the short answer is no. And it's primarily because of that concern of, it is primarily due to the issue of what kind of decisions or what kind of outcomes or inferences would a non-expert arrive at based on data they do not understand. And that is a limitation of trying to express this information in a big way. You raised a very good point about reverse engineering of data, and I very much liked Manus's presentation in terms of how do you prevent that. And there are a lot of different considerations we take into account. So for Western growers, for example, on a county-by-county basis, so the state of California is broken up into multiple counties. Some of these farming operations are quite considerable. When it comes to displaying data or analyzing certain data, because we are also always interested in protecting the plausible deniability, we simply do not show information if it fails to meet certain criteria. So one example would be, for every given commodity in a given county, there should be at least 3 separate producers who contribute to the aggregation, so that if you are one of those parties looking at this data, you can't tell if it is neighbor 1 or neighbor 2 whose data that is. You could do that if you were the only person there and just said, hey, that's not the data I submitted, so I now know directly about a competitor's operation. So there are guardrails we have in place to kind of make sure that the data is as not reverse engineerable to the best of our ability. Thank you.
Is there any additional?
Yes, thank you. My question is for William as well, about data quality, because we have a lot of different data providers, and we notice that they use different definitions for the same thing. So do you have anything in place, for instance, if you say, well, if you give us an address, the address should be the street name, postal code. How do you deal with different data definitions from different providers?
So the cheat code that I have used to this effect is the definition of a data dictionary. So when one goes out to different stakeholders who will be submitting data, you fundamentally have to tell them that you might not provide data that conforms to this format up front. We will convert that data into that format. If the data you have provided upon conversion fails to meet all these criteria, that will be flagged to you for the purposes of kind of letting you know that your data is not compliant with these standards. But it then kind of impacts their own personal analysis, because it's always the case of, it is about showing the value of sharing data. It can be very easy to kind of build out the case for kind of the education-based sales. So you make a really good case for why you'd like to learn about data, to learn about your organization. You can make the value-based sales that say better food safety corresponds to an increase in revenue here and a drop of costs there. But there's also the fact that you have to communicate that, very, very plainly, sharing data is also to your benefit by virtue of the fact that you're getting your own data house in order. So by highlighting the gaps that exist in a given organization's kind of data, you can actually help them patch those up and get better analysis. We prepare these kind of aggregated data dashboards. Something else that we do is also give them kind of a private kind of examination of their own data. So they can examine their own situation and then compare that and contrast that with data aggregated as a whole. And it helps them draw an easier picture. It also helps them kind of make the argument that, like, hey, look, we weren't getting this kind of insight before. We're doing it and also data sharing. So it's kind of an easier way to bait the hook there effectively.
Okay, thank you. And how long would you say it takes to set up
How long have I been doing this job?
For a dictionary, for instance? Does it take very long? Do you go around to different parties and ask them what's your definition and you make one general one? Or
So fundamentally, we would typically start projects with a cross-section of data. We define a data dictionary based on what we have at the time. We say, this is the template we're applying. Any objections, let us know. If not, we go forward. Takes about maybe... I'm going to say a month or two of like careful review to make sure we're covering everything if we've got a very large body of data to work with. And fundamentally, we remain flexible. If a data dictionary needs to be updated because a new participant has joined the program and they do it in a completely different way, we facilitate that. We want to try and do the best data practices possible. And so we change things and we communicate about those changes. So much of this is change management. You are doing something new. How do I reassure you that this is not like a terrible, scary thing?
Okay, thank you.
Thank you so much.
Hello, thank you for a nice presentation. And I'm actually having a question for online from Manos, but probably some of you can reply to that. Something got me about these data models that are implemented locally in the companies, and then they don't need to share the data, but then they kind of share the parameters, or they share this fake data with this generative data model. So you share a data is similar to yours, but anyway, if you put it like that, even though it's not real, it's still a very similar version. That then they don't want to reveal that they're actually selling horse meat instead of beef. So they introduce noise. So this is now the question that, don't we have the risk that when you put this data that is fake, and on top of that you add noise, and you have all this, it's a trend that we are generating more data, and I think that with AI we'll generate all these generative models, predictive modeling, that it will not get real data anymore. And do we have a way to differentiate that and to flag what is actually generated and what is actually real? And isn't it there a risk that in some years we will be flooded with data that we are not capable to differentiate what is actually realistic or real of what is actually predicted or generated?
I might start, if it's okay. Yes, please. So to that effect, what Manos is mentioning there is actually a fairly common practice in cryptography, known as salting, where you add a little bit of randomness to actually make it so that the distributions are concealed. This is a good practice to make sure that that data does not risk compromising those metrics like mortality rate. You otherwise raise a completely valid point about the generation of data, and in essence, if this data cannot be generated in a way that flags where these problems exist, it will be released at some point in time, or it will otherwise be aggregated by someone else, maybe not this private instance, but potentially by researchers who are generating private data because, oh, we're undersampling a class here, let's generate some synthetic data. They release that publication gets picked up, a model is trained using all that data, and of course the next researcher may unknowingly have included synthesized data. They then factor that into another project, and they're like treating that as real data. It is a very real threat to the kind of sanctity of data and its existence as a primary source, which is one of the reasons I advocate so strongly for sharing data. Let's try and get the data that is really real together first before we necessarily run to the generation of data, which will, pose a lot of problems for both academic analysis of food safety risk, but then also for industrial analysis, because I guarantee you there will at some point be a service that just floods data sources with bad data so that your problems are suddenly not so statistically significant. So very fair, very scary.
I think we can have this in the back and then one up here, and that would be the last questions.
I'll be super fast, and it's more of a comment than a question. So all these elements will need to be, and sorry, also to very inelegantly promote what I said earlier this morning, present in the summary, right? So the fact that the data that you use for the training is synthetic data or not, most likely to the extent to which this model qualify as either high-risk systems or general purpose AI models in Europe, but also in the rest of the world, as long as that model will, the model provider will want to market that in Europe, needs to disclose, for example, it's still in the making, but most likely the nature of the data, so whether it is personal, whether it is not personal, and whether it is synthetic. And this is already valid law. It's not yet applicable, as we discussed, but it will be in a matter of months. So I think it's interesting to reflect upon that and how distant is the current industry practice from a law that, in theory, will apply in a few months. Sorry, thank you.
Hugely appreciate you adding that. Thank you very much.
And then there's the last question here.
Thank you so much. I wonder if we understand that the data sharing is very crucial. And I wonder if you have an opinion in the data sharing could be mandatory, legally mandatory in several situations. I'm asking this because I'm working in food monitoring, nutritional composition, and it's very difficult, even in the obtaining information that it's available in the labels, and even being available in everywhere, online or in the supermarkets. Sometimes it's difficult to convince the producers to share that information. And the companies are obliged to share financial gains and losses, we as taxpayers have to declare our wins and our houses, everything. Could be an kind of a mandatory legal obligation to share some information. I don't know if you have any example.
So I have, it is a carrot versus stick approach, quite candidly. It is possible to both try and reward industry for sharing data. So saying, okay, you're sharing data, you're removing a burden of inspection from us as an agency, we will reduce our monitoring of you provided your data remains within certain tolerances we provide. There is the stick approach, which is provide data or we will begin fining you until you provide data. In terms of which one I find more effective or which ones I personally prefer, maybe I won't comment on that at the moment. But I can very much see the rationale behind obliging companies to share data beyond financial records, which of course they're required to share. Auditing on data is a thing that I do not believe there are mechanisms in place for in a robust and reliable way yet. I think that is a new challenge that kind of companies and regulators alike are going to have to evolve to address. Do you want to say anything about that, Leah?
No, thank you.
Okay.
Then I think we will stop this session. Thank you to all of you, but especially thank you to you, Leah, and to Will, and also to Manos out in cyberspace. Thank you for coming and for taking part of the discussion. And now there's lunch, and the program will start again 1:30.